Hello, my name is Ashish Srivastav and let us start discussion of paper FT-08 JEE Mains to 2025. Okay, so let us discuss first question number one. Okay, so first question is six identical rods are arranged as shown in figure. The temperature of the junction B will be. See, the word here identical rods is written, which means we can say that all rods have equal resistance. Okay, so let us draw a circuit. First rod, let's say it has some resistance. Then there is second rod, and then there is third rod, fourth rod, fifth rod, and sixth rod. Okay, now so point A is this one, and point B, and point B is this one, right? And this will be point C and this will be point D. Now we need to calculate the temperature junction at the junction B. So we need to collect the resistance before B and after B. So let us consider that all the resistance here are R. Okay. So you know these two resistance are in series, these two resistance are in series, and they both will be in parallel and they all then will be in series. So my equivalent resistance circuit can be written as, let's say this is point number A, then it will be R, this will be point number B. So I can write it as 2R, 2R, and then again one resistance R. Now they are in parallel circuit, so the resistance are in parallel, so their equivalent resistance can be calculated by 1 by R will be equals to 1 by R1 plus 1 by R2. And since R1 is equals to R2, so you can just say that 2R and 2R will be reduced to resistance R. Then your new equivalent circuit will be R, point B. This will be R, this will be R, they will be in series. This will be R, this will be R, and then they will be in series. So this resistance will become 2R. Okay. Now, at this point, in the question it is given that the temperature is 200 degrees Celsius, and at this point it is 20 degrees Celsius. Now, see, due to time, now, so temperature at B point can be written as, temperature at point B can be written as 200 minus T divided by R. It will be equals to T minus 20 divided by 2R. Okay. Now from here, if you will calculate it, you will find that temperature T will be equals to 140 degrees Celsius. T will be equals to 140 degrees Celsius. So option number C will be your answer here. Let's do second question. Find the total number of images formed by both the mirrors as shown in figure. Before solving this, you need to understand that image forms when two points intersects and there is only one point object. This is a point object. So from a point object, if I will take two rays and I will follow the law of reflection. What is law of reflection? That is angle I will be equals to angle R. Then I will be able to find the answer. Okay. So now from point O, your one ray will go like this. Your one ray will go like this, and when it will strike that, so there will be a reflection. The reflection will be like this. Okay, such that this angle will be equals to this angle. Okay. Now second row, I can take it here along this line. Okay. then it will reflect like this. So when I will extend it, obviously it's a plane mirror, so the image will be virtual only. So my first one image will be here. Let's call it I1. Now for the second point, similarly, let's say my one point is here. Okay. If I am taking this ray, let me choose different pen for this. So it will be like this. So it will reflect back as per the law of reflections. Okay. And second one you can take anywhere. Let's say I am taking it here. Okay. So again, it will reflect here. So, they will never meet here. So again, virtual image will be there like this. Hence, it will be I2. See, from anywhere, if you will calculate it, there will be infinite rays from an object. But we have to consider the most probable value, see. And a mirror only contains, plane mirror only can make virtual images. So, from this one mirror, it will be I1. And from this second mirror, it will be I2. So, there will be in total 2 images. Hence, your option number A is the correct answer. Okay. Always remember law of reflection will be followed here whether how many mirrors are there. Okay. Now, next question. A body with mass 2 kg, moves in x direction in the presence of a force which is described by the potential energy and displacement graph. So this graph is between potential energy and the displacement. Okay, that is potential energy is varying. Now, if the body is released from the rest, which means where the potential energy is constant at 10 joules. So at here, the velocity is actually 0. Okay. At x equals to 1 meter, then its speed when it crosses the x equals to 5 meters. When it crosses the x equals to 5 meters. And which is 5 meter point? This is my 5 meter point. Okay. And I have to calculate it from here. Okay. Now see, they are asking me regarding body. See, potential energy is varying. So I can say that some of its potential energy is getting converted into kinetic energy. So we can say that since total energy is constant, so loss in potential energy will be equals to gain in kinetic energy. Okay. Now here, the potential energy was 10. And now the potential energy is 2 here. Initially potential energy is 10 and now it is 2 here, right? So loss in potential energy can be written as 10 minus 2. It will be equals to gain in kinetic energy. Kinetic energy is half mv square. Initially it was at rest. So finally it will be equals to 1 by 2, mass is 2 kg into v square. 2 and 2 will get cancelled out. So v square will be equals to 8. Okay, 8. So from here I can say that v will be equals to square root of 8. It will be equals to 2 root 2 meter per second. Hence your option number C is the correct answer. Next question. In this question, we need to show a little bit of creativity. Okay, you have to imagine that consider a hypothetical radial magnetic field. What do you mean by radial magnetic field? A radial magnetic field from which we can say which is getting originated from a point and everything is going in the circular kind of direction. Okay, that is what we mean by radial magnetic field. Now find the magnetic force on the closed current carrying ring. It is given here. Okay. Now, if it were some uniform value, right? If it were some this magnetic field, you cannot say uniform because with the distance it is varying, right? So we cannot calculate directly force here by using ILB. Okay. So here we need to use the integration. So for that, let's let us consider a small element here. Let us consider a small element here. Let's call it length dl. Okay. So on the length dl, my force df will be equals to due to this. See, we have to calculate for all the directions for B naught. So we are just talking about this one particularly. So it will be equals to df will be equals to obviously ILB. So it will be B naught into current is my I naught and this dl. So my total force will be equals to integration, complete integration of this value. So it will be I naught B dl. Okay. Current is constant, magnetic field magnitude is constant. So we have to integrate dl. dl means complete circumference. So it will be equals to I naught 2 pi r B naught. Okay. So this is the magnitude of the force. Now let us talk about the direction. Okay. Because option number B and C, one is saying inward, another one saying outward. Now using the left hand rule. See, let's talk about this point. Let's talk about this point particularly. So here my current direction is up, right? Magnetic field direction is in this direction. So from here I can say that force is acting outwards. Okay. So hence option number C will be the correct answer, since this represents shows that the magnetic force direction is in the outward direction like this. Okay. Now this was a question from atomic physics. A hydrogen-like atom. See carefully. You see here, it is written as hydrogen-like atom. It is not hydrogen atom. Hydrogen-like atom means there will be a one electron in the orbit, but there can be more than one protons or more than one nucleons inside the nucleus. So your charge will also, your charge of nucleus will not be the same as in hydrogen atom. Okay. See what happens. Let me tell you about a little bit theory here. So let's see. This is my positive nucleus and this is my electron outside, right? See, nucleus is concentrated here, so you can directly calculate it. Okay. So whether it's charged or not, so it doesn't matter. So we can treat it like hydrogen atom. But if there are more than one electrons, then electron will interact, and so it will become complicated. So for that we use very different topics that comes under your basically many body problems. That is a lot of research going on these topics. But moving on from that, see this hydrogen like atom, which means it has only it has only one electron in the outermost shell. Now they are saying that if there is some excited state from which principal quantum number n and come to first excited state by successive emitting two photons of energy 10.2 electron volt and 17 electron volt, this atom from same excited state. Okay. Now that is now can make a transition to second state by successively emitting two photons of energy 4.25 electron volt and 5.95 electron volt respectively. Now choose, okay. So we have to find the value of Z and N. Now, initially it is saying that from any value of excited state, let's say there is some value N, it is coming to first excited state. First excited state means N will be equals to 2. Okay. It is coming from N equals to 2 like this, and it is emitting two photons, one of energy 10.2 electron volt and another one from energy 17 electron volt. So you can say that the energy difference between these two values energy levels will be 10.2 plus 17, that will be equals to 27.2. Okay. Now you know difference in energy level. Can you see? We know that energy of any hydrogen like atom is actually 13.6 G square by N square. Right. So my difference in energy for the first case can be written as 13.6 Z square 1 by 2 square minus 1 by N square. It will be equals to 27.2 electron volts. Okay. This will be equation number 1. Now, for equation number 2, it is saying that now the transition is coming and it is coming to the second excited state. Second excited state means now it is coming from some excited state N to N is equals to 3. Like this. And it is emitting 4.25 electron volts and 5.95 electron volts, these two values. Okay. Now, so from here I can say that change in energy will be equals to 13.6 Z square divided by 1 by 3 square minus 1 by N square. It will be equals to the sum of these two energies, and that will be 10.2 electron volt. Okay. Now see, this is equation number 1. This is equation number 2. Okay. And now there are two values Z and N. So we have two variables. We have two equations. So from here we can solve for the value of N and Z easily by any method, by substitution method or by elimination method, whichever method you want to follow. And then from there you will get that my value of N will be equals to 6 and Z will be equals to 3. So option number B is the correct answer here. Okay. Now, a cyclic process ABCA is shown in the VT diagram. The same process in PV diagram can be written as. Okay. So first of all, see, whenever you see these kind of question, always take look towards the constant values. Always look towards the constant values. Okay. See, for example, in process BC, what is constant? Volume is constant. Okay. So I can say that from here my my volume should be constant in the PV diagram as well. Okay. Now see, in option number B, my volume is not constant. Okay. My volume is not constant throughout the BC's throughout this BC. So this option can be eliminated directly. And the same thing is happening here in the option in the cycle BC. Volume is not constant. So option number C is rejected here too. Now let us talk about the second value here. In this second value, my temperature is constant. In process AC. In process AC, temperature is constant. Okay. So we can say that is an isothermal process, and for this my pressure will be inversely proportional to V. And since in this process of AC, that is the process that is coming from C to A, my volume is decreasing. If my volume is decreasing, so my pressure should be increasing, right? But here in the CA process, it is not happening here. So hence option number A will be rejected here too. Hence option number D will be the correct answer. Okay. Here my volume is constant, and here in the process CA, my pressure is increasing with inversely proportional relation. Here you can clearly see that P is inversely proportional to V for process CA. Hence option number D is the correct answer. Okay. Now, question number 7. Figure shows an Amperian path A, B, C, D, A. See, point number A, B, C, D, and A. This is my path. Okay. Now, part ABC is in vertical plane and part vertical plane PSTU, while CDA is in horizontal. So see here, Amperian loop is not in one plane. There are two different planes which might be perpendicular here as per the figure. I can say that. So for that, they are talking about, they want to calculate B dot dl. Now, from Ampere circuital law, I know that B dot dl is equals to mu naught summation of I, that is total current. That is total current. See, now let's see. There is current I1, I3, I2. Okay, there are three values of current. See, I1 is in the same plane. I2 is also in the same plane in which it is, but I3 is moving from one plane to the another plane. Okay, so now for plane ABC, so my total current will be, let's say, I will be equals to here. So A total sum, it will be equals to, for the loop ABC, I1 is coming, right? So I1 will be there. Okay. And for this, I3 is also coming, right? Now, for the loop, this ACD, I2 is coming, but I3 is going out. So it will be equals to I1 plus I2. I1 plus I2. So from here, I can say that my B dot dl will be equals to mu naught I1 plus I2. Hence, your option number D will be the correct answer. Now, a particle, question number 8. A particle A with mass 2m, mass is given as 2m, is moving with a velocity u, and it hits a particle B of mass m at rest. Find the value of n if change in de Broglie wavelength is this much, and treat the collision elastic. See, this question is a combination of two concepts. First concept, for the de Broglie wavelength, that we know as lambda is equals to h upon mv, which shows the wave behavior of the particles. Another another thing they are talking about, that collision is elastic, which means momentum will be conserved and also the coefficient of restitution will be 1. Okay. Now, for conservation of momentum, they are saying that a particle A with mass m2m is moving with a velocity. So initially there is one particle A and this one is particle B. So it is moving with the u velocity and it is at rest. Now after the collision, what happens? See, since this is elastic collision, so the both will not stick together and coefficient of restitution will be 1. So let's say it becomes a velocity of v1 and it becomes a velocity of v2. Okay, and its mass is 2m and its mass is also 2m and its mass is m as given and its mass is m. Okay, now so from conservation of momentum, I can write that 2mu plus 0 will be equals to 2mv1 plus mv2. From here I can cancel m. So from here I can say that 2u will be equals to 2v1 plus v2. Let's say this is equation number 1. Now since this process is elastic, so my coefficient of restitution will be equals to 1 and it will be equals to v2 minus v1 divided by u2 minus u1. Simple, right? So let us do that. So See, in the denominator, one value is in rest, so it will come only U. Okay? And in the above value, it will come as V2 minus V1. This will be, from here I can say that U will be equals to V2 minus V1. That is my equation number 2. Okay? Right, so you can just put these values over here. Okay, now what they are asking about, find the value of n for the change in de Broglie wavelength. So change in de Broglie wavelength will be equals to h upon m u, I mean mass of first particle, that is mass of a particle, into its velocity minus, we can take their magnitudes, it change in, so we can do final minus initial minus 5 and we can take the absolute value for the positive value, and it will be equals to ma and its velocity in finals, that is, let's say v1 in this case. Okay, now while solving equation number 1 and 2, see there is v1 v2 v1 v2 v1, so these two equations are also in, sorry, these two equations are also in two variables. So by putting the values over here, I can calculate that v1 will be equals to u by 3. Okay, now putting the value here, so delta lambda will be equals to h by mass of A is actually equals to 2m, and in brackets it will come as 1 by u minus 3 by u. Okay, so it will be equals to delta lambda will be equals to, from here if I calculate it, so it will come as h by mu. Now comparing this value from there, so I can say that here n is equals to 1. N is equals to 1. Okay. So let's come upon to the question number 9. That is the question from meter base. Simply Wheatstone bridge will be there. Okay. Now, in a meter bridge, as shown in figure, it is given that resistance Y is equals to 12.5 ohm and that balance is obtained at 39.5 centimeter. From end by jockey, so here's some jockey. Now, after interchanging the resistance X and Y, a new balance point is found at distance I2 from end A. Then what is the value of X and L2? Okay, so we will directly apply here. Wheatstone bridge. See, here I can write that X by 39.5 will be equals to Y by 100 minus L1. It will be equals to, see, 100 minus L1. So 100 minus 39.5 will be equals to 60.5. Y value is given here. So from here I can calculate that X will be equals to Y, that is 12.5 multiplied by 39.5 divided by 60.5. And this value will be equals to 8.16 ohms. Okay, so I can say that option number A and option number D are completely eliminated from here. Now let us calculate the distance. Now after that, since our null point is changed, right, after that my null point is changed, so now jockey will look like this. Okay, let's say it is coming at L2. Okay, so it will be L2 and it will be 100 minus L2, and resistance are changed. There will be Y, there will be X. So from here I can say that Y by L2 will be equals to X by 100 minus L2. Now we know the value of x and we know the value of y. So it will be equals to 12.5 divided by L2. It will be equals to x. What is the value of x? 8.16 divided by 100 minus L2. This is a simple equation. You can easily calculate from here that my L2 will be equals to 60.5 centimeters. Hence option number B will be the correct answer. Now, question number 10. A copper wire Young's modulus equals to 1 into 10 raised to the power 11 Newton per meter square of length 8 meter and steel wire modulus equals to 2 into 10 raised to the power 11 Newton per meter square of length 4 meter, each of cross section 0.5 centimeter square are fastened end to end and stressed with a tension of 500 Newton. Then my elastic potential energy of the system will be equals to. Okay, so the situation is like this. For example, there is one bar of copper. There is a copper wire. Okay, and there is on another steel wire. Both are of different length, but their area is same, so the junction will be the same. Now they are saying that they have been stressed by a force of 500 Newton. So obviously, since both are elastic materials, so they will experience a stress, right? And then they will try to come back there. That's a property, and their Young's modulus is given. Now, elastic potential energy of the system is asked. So we already know that my elastic potential energy is nothing but half into stress into strain into the volume, right? Now here, what will be the stress? Stress will be nothing but my force upon area, right? And also I know that my Young's modulus is equals to stress upon strain. From here I can say that it will be equals to T upon A divided by strain. Strain will be delta L by L. Delta L by L. Okay. So from here, T by A will be equals to Y delta L by L, or also elongation in the one wire will be equals to T by A into L by Y. Okay. So now your total. So now for this question, total energy will be equals to 1 by 2 into T by A into delta L for the copper divided by length of copper multiply by its volume. Okay, plus delta L of steel divided by length of steel multiply by volume of steel. Okay. Now volume of steel will be nothing but area into its length. Area into its length. Okay. Tension is given, area is given, delta L you can calculate it from here. Okay. Delta L you can calculate it from here. Y is given, T and A, everything is given. Okay. So from here, when you will put all the values here, then you will get that total energy will be equals to 0.25 joules. Okay, you can easily perform the calculation. See tension will be equals to 500 Newton only. Area is 0.5 centimeter square. Now length for copper is 8 and Y is given there. Okay, so you can easily calculate delta here. Let us come up on to the next question here. Okay. Now, displacement time graph of particle executing simple harmonic motion is shown in the figure. Then the equation of SHM is given by. Then the equation of SHM is given by. See, we know that standard equation standard equation is y is equals to a either sine omega t or cos omega t, but since it is given as sine, so we will consider from sine a sine omega t plus phi. Okay, so my task is to find the amplitude, where amplitude is 10, and then omega and then phi. See, now at t equals to 0, my displacement is equals to, okay, not y, actually write it at the x, because with x it is given. So my a will be equals to 10, obviously. Now let us analyze from the graph. Okay, see, what do you mean by omega? Omega will be omega is the angular velocity, right? And omega is actually equals to 2 pi by t, right? And what is time period? Time period is to complete one cycle. For example, let's suppose this is a wave, right? So how much time it is will take from coming here to coming here, so it will be the time period, right? Simple. Now see, from here, from this point to this point, I can say that, see, let's suppose, let's extend it, so at some time t it will come here, right? So till here it will take half of the time. It will just take half of your time, right? So from here I can say that, right? So 7 minus 1, it will be equals to 6. So from here I can say that my omega will be equals to pi by 6. The time difference between them is pi by 6. Hence my omega will be equals to pi by 6 here. Okay. And see, it is starting from y. So, it will go like this. And then it will come here like this. Till here. Right. So at this point, my phase will be equals to 5 pi by 6. Okay. So from here, I can say that x will be equals to a, that is 10 sine 10 pi t by 6 plus 5 pi by 6. Hence your option number B will be the correct answer here. Okay. Now, question number 12 is a direct question. In an LCR circuit, VR circuit of voltage V, VR, VL, VC are voltage of source, resistance, inductance, and capacitor at any instant. Then choose the correct relation. That is VR, VL, and VC. Okay. So it is a direct question that the V always equals to VR square plus VL minus VC square. Okay. And also its impedance, we know that impedance we can easily calculate. It is calculated using that only. See, I know that my impedance is always equals to R square plus XL minus XC will be square, right? So I know that voltage is equals to current into impedance, and from all the values current will be same. For all the values, my current will be same because they are in the series circuit. So from here we can easily obtain that VR square will plus VL minus VC whole square. So it will be option number A. Your option number A will be the correct answer. So let's do question number 13. The variation of photocurrent with potential difference V in photoelectric effect experimental setup for two frequencies of incident radiation keeping intensity constant, that is energy received per second per unit area constant in both the experiments, is best represented by, see, they are saying that intensity is constant. Intensity is constant. And what is intensity? Intensity is energy per unit area per unit time, right? Energy per unit area per unit time. Now, see, after this, when energy is actually in photoelectric effect is represented by NH mu, where N is number of photons. Okay. Now, see here, if my H mu, that is frequency, it will vary. So my number of photons will must vary according to this, right? So this is energy per unit area per unit time, right? So now, according to this, my photocurrent should be different for different frequencies. So option number A is wrong. Now, as my H mu, that is mu, will increase. So to keep intensity constant, my number of photons per unit time must decrease, right? So for more frequency, less photocurrent. If for frequency, then my current must be less. So option number B is also wrong. And option number C is also wrong. Only option number D is showing that, that is if my frequency is actually greater, that is F, or frequency is greater, the number of photons per unit time will decrease. So electrons per unit time will decrease. So current will decrease for higher frequency. Hence, option number D is the correct answer. Now, question number 14. A ball moving with a velocity of 2 meter per second collides with another stationary ball of double the mass. If the coefficient of restitution is 0.5, their velocity after the collision will be. So it's not elastic collision, obviously, because coefficient of restitution is not 1, it is 0.5, but so there will be some loss in energy, we don't know. But it might be in the form of heat or it might be form of any bonding energy, we do not know at all. Okay, but let us talk about initial condition here. So a ball is moving with a velocity of 2 meter per second, okay, and head on with another stationary object and its velocity is equals to 0. Now after this, with another ball of double the mass, if its mass is m, then its mass will be 2m. Okay, now if the coefficient of restitution is 0.5, their velocity after the collision will be, for example, now there are two balls. Let's say its velocity is v1, its velocity is v2, its mass is m, its mass is 2m, because mass will not change. Okay, because nothing is breaking or nothing is getting attached. Now, see, by conservation of momentum, by conservation of momentum. So my initial momentum will be, because of this, that is 2m plus 0. It will be equals to mv1 plus 2mv2, right? So from here I can cancel out all the masses, this m, and this m. So from here I can obtain the equation as v1 plus 2v2, it will be equals to 2. Let's call it equation number 1. Okay, now for the second part, since coefficient of restitution is given as 0.5, that can be written as 1 by 2. So it will be equals to v2 minus v1 divided by 2 minus 0, because initially one object was at 0 and this will be the difference in the velocity. Okay. So from here I can clearly see that v2 minus v1 is equals to 1. This is equation number 2. Okay. Now, solving equation 1 and 2 by whether elimination method or by any other method as per your choice, you can see that my V1 will be equals to 0 and my V2 will be equals to 1 meter per second. 1 meter per second. Hence your option number A will be the correct answer. Now, next question. A light planet is revolving around a massive star in a circular orbit of radius r with a period travel of revolution t. If the force of attraction between planet and star is proportional to r raised to the power minus 3 by 2, then choose the correct option. Okay. Now see, force of attraction between planet and star is not r raised to the power. In general, it is r raised to the power minus 2, but this time it is not. At this time it is r raised to the power minus 3 by 2. So it is a different case. Okay. So, for example, there is one planet here and there is one star. Okay. And it is revolving around it like this. Now, there will be some force between them, right? And it will be the necessary or required gravitational force. Okay. In general, F is equals to gmm upon r square, but this time it will not be because some different relation is given. Let's talk about this is something about different universe. We don't know. Okay. So I can say that mv square by r, it will be equals to g mass of star, mass of planet divided by r raised to the power 3 by 2. Okay. This will be mass of planet. MP and MP will get cancelled out. And we can resolve this r also. So from here I can say that my v square will be equals to g ms r raised to the power 1 minus 3 by 2. R raised to the power 3 by 2. So from here my v will be equals to square root of g mass of star r raised to the power minus 1 by 2. Okay. Now they are talking about time period. So time period will be equals to distance upon speed. So distance will be 2 pi and the radius r divided by velocity. Okay. So 2 pi r raised to the power 1 divided by g ms raised to the power 1 by 2, and this r will also be right. So this r will also be equals to minus 1 by 2 raised to the power 1 by 2. Okay. Now let's say all these all the values we need to take as constant equals to k, constant. So I can say that from here that my time period will be equals to some constant k r raised to the power 1 plus 1 by 4, that will be equals to 5 by 4. And in the question we are asking about t square. So from here t square will be directly proportional to r raised to the power 5 by 2. Hence your option number C is the correct answer. Now, question number 60. A force exerts an impulse I on a particle, changing its speed from u to u. The applied force and the velocity are oppositely oriented along the same line. The work done by the force is. Okay. So we know that work done by the force is nothing but change in kinetic energy. So work done by force is nothing but change in kinetic energy. So it will be equals to 1 by 2 into mass V2 square minus V1 square. So it will be equals to 1 by 2 m 1 by 2 m, and V2 square minus V1 square will be nothing but 3. So it will be 4u square, and it will be u square. So it will be 4u square minus u square. So it will be equals to 3 by 2 m u square. Now, see, right now the answer isn't still here. See, we have to find the answer in the terms of impulse. Now, what is impulse? Impulse is nothing but change in momentum. Now, see, the applied force, the velocity are oppositely oriented along the same line. Okay. So, for example, if my initially particle was going like this, so now it will go like this. Okay. Because the force applied and the velocity are in the opposite oriented. Like, for example, if velocity is like that, force will be applied here, and it's changing its speed from u to u, which means it is going in the backward direction. Okay. So my change in momentum will be equals to final momentum minus initial momentum, right? So it will be equals to 3u. See, it will be equals to u minus of 2u. Why? Because it's in opposite direction. So it will be equals to change in momentum. It will be equals to 3u into mass. Change in momentum will be with the respect of mass, right? So this so this 3u can be replaced here as so you know m3mu, so it will be 3um. Okay, 3um, it will be equals to impulse. Okay, now 3 by 2 into m into u, this 3mu is nothing but I, so it will be equals to 1 by 2 IU. Hence, your option number B is the correct answer. Now, question number 70. In the figure, magnetic energy stored in the coil is. We know that energy is nothing but 1 by 2 Li square. L is given, I we need to find. See, this is a direct current, so I can calculate the current here directly. So I will be equals to V by R. V is 10 and R is 2. So my current will be here 5 amperes. Okay. Hence energy will be equals to 1 by 2 into 25. 2 and 2 will get cancelled out. So it will be equals to 25 joules. Hence option number C is the correct answer. See, this is a this is an easy question. But if instead of AC current would be there, then the condition would be a little bit different. Okay. Now, question number 18. This looks like a projectile motion. A particle is projected as shown in figure. If the particle strikes at the wall after 1 second, then the ratio of x by y will be. And the ratio of x by y will be. Okay. See, x is horizontal and y is vertical. Okay. If any questions comes for more than one dimension, there is a rule. treat all directions differently. Treat all the directions differently. Okay, in any case, even in the inclined plane case also, see, in the inclined plane, horizontal and vertical both will be different. There will be acceleration horizontal as well, so treat them different and find your answers. So that's easy. Now for let's do that first. So in the x direction and in the y direction. Okay, in the x direction, in the y direction, my velocity displacement that we need to calculate is actually x, right? That will be my sx. My velocity in this direction will be equals to 50 cos 37 degrees. See, 37 and 53 degrees, there is a triangle. We know that it has sides 3, 4 and 5. It has sides 3, 4 and 5, right? So from there we can calculate. And acceleration in this direction is actually equals to 0. Okay. And time period we can easily calculate whenever it is required. Okay, let's say time period is t. Now, Sy will be equals to y only. Vy will be equals to 50 sine 37 degrees. And Ay will be equals to minus g. In here, I am taking it as minus 10 meter per second square because I am taking upside as positive and downward direction as negative and time t. See, important fact is here, everything is different, but time is a scalar quantity, so time will be constant. See, for example, if I am moving horizontal, if I am getting vertical, so point will be same. So covering that y distance, x distance, the time will be same. Okay, so let's calculate. X will be equals to, from second equation of motion, x will be equals to, or you can say sx will be equals to initial velocity of this. So it will be 50 cos 37 degrees into time. Acceleration is 0. So this is equation number 1. Sy will be equals to 50 into sine 37 degrees ut. Okay, and time is 1 second given everywhere. Okay, so I can just calculate it here. So it will be 50 cos 37, right? So 50 cos 37 is actually equals to 40. Why? Because cos 37 will be equals to 4 by 5. So it will be equals to 40 meter per second. This is 5, this is 4, this is 3, and if this angle is 37 degree. Okay. So from here I can calculate, I can see that it is 40 meters. It is equals to 40 meters. Now for this value, 50 sine 37 t minus 1 by 2 into g is 10 and t square is nothing but 1 square, right? So it will be equals to 50 into 3 by 5 into 1, obviously, minus it will be 5. So it will be 10. So it will be 30 minus 5. It will be equals to 25 meters, right? So from here, I can calculate the value of x by y. It will be equals to 40 upon 25. Okay. 40 upon 25. Now we need to calculate it in the decimal system. So 25.25, right? And 150. So it will be 1.6. So answer will be option number B. Now question number 18. A particle is projected as shown in figure. If the particle strikes, okay, that's the same question. That's our solution part. Next question is, for the LR circuit as shown, ratio of currents I at t equals to 0 and at t equals to infinite after closing the switch. Okay, so after closing the switch, as soon as we close the switch, we need to analyze a situation and we need to analyze another situation. Okay, so now see, this is a direct current. Okay, as soon as we will after switch close, so at time t will be equals to 0. Okay, so my current will flow here. My current will flow here at t equals to 0. So from here I can say that I at t equals to 0, it will be equals to V by R. I will be equals to V by R. Let's say this is V. And the resistance, since they are in series, so if current will flow directly like this and no current will flow from here, so it will be R plus 2R, so it will be equals to 3R. Now, at t is equals to infinite, there will be some magnetic energy. So this is a so my current will flow from here. It will not go here. It will directly go from this path. So it will not, because it will not offer anything. So for t equals to infinite, at t is equals to infinite, my current will flow from here at t equals to infinite. So only resistance will be because of this, so it will be equals to V by R. Again, this is a direct current, that's why we are talking about this. Okay, if it won't be a direct current, then there will be some definitely induction as well, and that will provide an external resistance of XL, that is called as induction impedance. But here it will not give you any kind of induction impedance because there is DC current. Because there is DC current, there is direct current. Okay, and so the ratio between them will be equals to V by 3R. Okay, the ratio will be V by 3R, V by R. V and V cancels out, R and R cancels out, so it will be equals to your 1 by 3. Hence your option number D is the correct answer. Okay, question number 20. This question is from dimensional analysis. Okay, so in an electron gun, emission current from the cathode is given by this equation: AT square e raised to the power minus b by kt. K is equals to Boltzmann constant. A is some constant value. Okay. Now the dimension formula for AB square is same as. Okay. See, there are two more important concepts here, that dimension in left hand side should be equals to dimension in right hand side. That is what we call principle of homogeneity. Principle of homogeneity. Okay. Now, after this, AT square e raised to the power minus b by kt, here, this value, whatever comes over e raised to the power, this is a dimensionless quantity. This is a dimensionless quantity. Okay. So, b by kt dimension will be equals to m0 l0 t0 or k0, it will be completely dimensionless. Okay, and for those two conditions, for values to be dimensionless, their ratio or dimension will be equal. So from here I can say that dimension of b will be equals to dimensions of kt. Okay, let's say this is one. Now see, this part will not offer any dimension, so completely it will be offered by AT square, right? So from here I can say that dimension of I will be equals to dimension of A and dimension of T square. So from here I can say that dimension of A will be equals to dimension of I and dimension of T raised to the power minus 2. Okay, this is 2. Now we need to find the dimension of A B square. So dimension of A is I T minus 2. Dimension of B is KT. So after squaring there, it will be K square T square. Okay. So my answer will be I K square. Okay, because T minus 2 and T plus 2 will become T raised to the power 0. Hence your option number C is the correct answer. This isn't a very difficult question. This is a very easy question. So solve all the kind of dimensional analysis like this only. So what you have to do, you just have to take each quantity for their properties and solve for them. Next question. A sphere of radius 10 centimeter. A sphere of radius 10 centimeter and density 500 kilogram per meter cube is under water of density 1000 kilogram per meter cube. Okay. The acceleration of the sphere is 9.8 meter per second square up in the upward direction. Then viscosity of water is 1.0 centipoise. If g is equals to 9.81 meter per second square, find the velocity of sphere in the nearest region. Okay, so this is a question from the concept of it will contain the concept of Archimedes principle, buoyant force, and the viscosity. Okay, so concept here will be 3: viscosity, Archimedes principle, or you can say buoyant force. Okay. Now they are saying a sphere of radius and is underwater, and water's density is this much, and the acceleration is in the upward direction, and viscosity is this one. Okay. So from the buoyant force, I can say that weight it will be in the left, it will be equals to in the right. Okay. So let us calculate it now. So volume of a sphere that is submerged, is equals to 4 pi 3 pi r cube g, right? Okay, so from here I can say that 100 multiplied by 4 by 3 pi r cube into g, that is rho v g, okay, minus 500, that is density of the radius, into 4 by 3 pi r cube g, and obviously there will be some resistance to the viscosity, and viscosity will be equals to 6 pi eta r into the velocity. It will be equals to the total weight. It will be equals to the total weight, that is 500 into 4 by 3 pi r cube a. Okay. So viscous force, buoyant force, and the gravitational force all are acting in these directions. Okay. Now, after we calculate the value of pi, r, and g is given as 9.8 minus 500. So let us put the values here. Okay, so viscosity of water is 1 centipole, so it will, so instead of eta it will come, radius of a sphere is given. Okay, so from here I can, after I put the values, I can calculate it as 0.2 divided by 3. It will be equals to 6 into 10 raised to the power minus 3 into V. So from here my velocity will be equals to, 0.2 divided by 18 into 10 cube. It will be equals to 200 divided by 18, and we can get the answer nearby 11 meter per second. Okay. Now, how to do the calculation? I know it's a little bit topical calculation. See, pi is coming everywhere. So pi is something that we can cancel out directly. Okay. Radius value is given, g value is given, eta value is given. Okay. So we can just directly calculate it from there. And we need to convert every unit into SI unit as well. For example, 1 centipose will be equals to 10 raised to the power minus 3 poise. And here 10 centimeter will be equals to 10 into 10 raised to the power minus 3 meter. So 10 raised to the power minus 2 meters, like this. Next question. This is an interesting question. Okay. A conducting frame, just a second. A conducting frame is placed in a horizontal plane as shown in the figure. The two sides are parallel and separated by a distance of 0.5 to 5 meters. A massless conducting rod can slide without friction on the frame. So we do not need to consider any friction. The total resistance of the circuit is 40 ohm. Then the rod is connected to a 0.2 kg mass. Okay, by massless cord which passes over massless frictionless pulley. So everything which is unnecessary, it's either massless or frictionless. Now, a uniform magnetic field of 2 Tesla points vertically upward. Here the things get interesting. Okay, then the voltage of the battery is 100 volt. Then find the constant velocity in meter per second with which rod and mass eventually move. Okay, so basically there is one value of rod. It is okay. There is one resistance and there is battery of 100 volt. Okay, so when it will move with some velocity, so there will be so there is a magnetic field. So there will be, it will experience a force, so there will be some velocity. Okay, there will be some velocity here. So now here it will experience a gravitational force. Okay, now because of that it will experience a magnetic force as well. Now, since they are saying that it is a constant velocity, so my net force will be equals to 0. So there are only two forces acting on here. First one is gravitational force and second is magnetic force. Okay. So we have to equate them. So it will be equals to mg. Mg will be equals to, since the movement between the direction and the magnetic field is perpendicular, so it will be I into L into the magnetic field B. Okay. So from here, my current will be equals to, my mass is 0.2, G I can take 10, divided by length of the rod is, what is the length of the, what is the length over here? 0.2, 0.25, right? And the magnetic field's value is 2 Tesla. Okay. So it will become 0.1. So it will become 1. So 1 by 0.25. It will be equals to 4 amperes. Now we have found the current. Now the current here is this much, right? So my EMF will be, okay. So my EMF that will be induced will be, we need to find that. Okay. Now see. For example, due to this change in the magnetic field, there will be some induced EMF, right? So that induced EMF plus this divided by this, that will be the total current, right? For example, their current is 4 ampere, and since it is moving like this, so there will be induced EMF. Induced EMF, it will be equals to E. Okay. So my current should be equals to 100 plus that EMF divided by 40. Okay. 100 EMF divided by 40. So from here I can say that EMF will be equals to 160. Sorry, not one. Okay. Just a second. So from here I can calculate my EMF to be equals to 160 minus 100, it will be equals to 60 volts. It will be equals to 60 volts. Okay. But my task is to find out, see, EMF we have calculated, right? But my task is to find out the velocity to generate this much EMF. Okay. Now we all know, now there is one direct formula. We know that EMF is equals to nothing but BLV. EMF is 60, magnetic field is 2, length is 0.25 into velocity. Okay. So from here my velocity will be equals to 60 by 2 into 0.25, that is 30. And from here you can calculate it, it will come equals to 120 meter per second. Okay. So now, oh, what it is saying that my rod must move with the velocity of 120 meter per second. So there will be some change in magnetic flux. Okay, there will not dB. There will be some magnetic flux. Okay, due to which there will be induced EMF, and since it is a current carrying loop, so it will experience a force also, and that force is nothing but ILB. So using these concepts, we calculated that velocity is equals to 120 meter per second. Let's come up on to the next question. A string fixed at both ends vibrates in a resonance mode with a separation of 2 centimeter between two consecutive notes. For the next higher resonance of frequency, the separation is reduced to 1.6 centimeters, then the length of the string is. Okay, so let's say there is a string, this is a NAT. Okay, just Let me try it again. Let's say there are two fixed strings, two fixed length, okay, and there is one string. Now they are saying that when you will, so it will be kind of standing wave, right? So they are saying that separation between two consecutive nodes, like for example, it is moving like this. Something like this, okay. So they are saying that the distance between two consecutive nodes is 2 centimeters, okay. So I can say that this is wavelength, so lambda will be equals to 2 times of separation between them, 2 into separation, right? Now the total length of the string will be, n times of the wavelength, obviously, because this is a standing wave, right? So n lambda by 2, it will be equals to the total length, right? Since it is a standing wave, so we can write it like this, because there will be n by 2 lambdas, there can be no, from here n into lambda will be equals to 2 into 2 centimeters, so it will be 4. And since everything is in centimeter here, so we do not need to convert it into units, but by 2 it will be equals to length. So from here it will be 2 here, okay. So 2n will be equals to L, so this will be my equation number 1. Now in the second case they are saying that for the next higher frequency this separation is reduced for 1.6 centimeters, okay. So now your new lambda will be equals to 3.2. And for the next resonance, so we have to take n plus 1, right? So for the n plus 1 nodes, so now for the higher frequency, multiply by 2 into 1.6 divided by 2. 2 and 2 will get cancel out. It will be equals to L, equation number 2. Okay. See, length of string is not going to change because it is constant between 2 points, right? So you can just put the value of 2n over here. Okay, so you can just put the value of 2n over here. So it will be equals to 16n. 16n plus 6 will be equals to 2n. Okay, and from where when you will calculate value, see again these are two equations, two variables, so you can just solve it. For this, the value of n will be equals to 4 and L will be equals to 8 centimeters. So my answer will be L equals to 8 centimeters. Okay. It's 1.6. Next question. One slit of Young's double slit experiment is covered by a glass plate of mu1 equals to 1.4 and the another glass plate with mu2 equals to 1.7 of same thickness. The point of central maxima on the screen before the plates were introduced is now occupied by the third bright fringe. Find the thickness of the plate. Okay. Now understand this point. See here. See, this is a direct question from the formula, but first I will make you understand the concept here. So what is concept here? See, for example, this is a Young's double slit experiment. One light is coming from here, one light is coming from here. Okay. Let's say the central bright fringe is happening here. Okay. And where will the central bright fringe? When there will be no any kind of path difference. Okay. This will be the central fringe for n equals to 0. Like that is no any path difference. Now they are saying about, see, the path difference is actually because of the speed of light. Now since there are two different, uh, refractive indexes that are placed of the same thickness in front of them. Okay, now here at this point both will not reach at the same time. Why? Because here and here time will be different, so they will reach at this point at different time and there might be a phase difference. So what is it saying? That when they are at this point, when they are at this point, at this point they are in the same phase. That's why they are making a central bright fringe in the third fringe. Okay, why? Because at this point they will be in the same phase. So and the velocity will be depending upon the obviously refractive index, because refractive index is nothing but c by v. So from here v will be equals to c by mu, and from here we can derive the formula later on by the help of refractive indexes. Okay, in this case, let's say thickness is t, that is for t time, that is for the t distance it has covered a velocity of v. Okay, so in that time, my since both have thickness t only, so both will spend same time here, so both will have different uh, both are there for the same distance. Okay, only because of the time lagging here, time will be equals to distance, that is t divided by v. This will be different for both the places, which will create a phase difference or the path difference here. So for this we know the formula, that mu2 minus mu1 will be multiplied by the t. It will be equals to 3 lambda. Why? Because it is coming at the third fringe, right? It is coming at the third fringe, hence 3 lambda. Okay, the formula is actually mu2 minus mu1 is equals to n lambda. So we know the value of mu2, that is 1.7 minus 1.4 into t. It will be equals to 3 into 4000 into 10 raised to the power minus 10. So from here I can calculate that t will be equals to, in which units they are saying, in micrometers, right? So it will be equals to 0.3. So 3 divided by 0.3, it will be equals to 10. It will be equals to 10. So 10 into 4 into 10 raised to the power minus 7. So from here I can say that it is 4 into 10 raised to the power minus 6 meter. That is equals to 4 micrometers. So that will be your final answer. Okay, so this let me write the answer here differently. So it will be equals to 4 micrometers. Question number 25. In the arrangement as shown in the figure, the potential difference VB minus VA will be equals to, and V0 is equals to 55 voltage. Okay, so see, we know that Q is equals to CV. We know that Q is equals to CV, right? V is given, C we need to find C. These three are in series, these two in parallel, and this one is also in the parallel with this. Okay, so these two will become 2C0, and these three will C0, 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 C0. Okay, so they will become C0 by 3. And this will be C0 by 3, it will be 2C0, and it will be 1 by C0. So since these will be in the parallel. Okay, and in parallel we can just sum it up again. So my equivalent resistance. My equivalent resistance between them, it will be equals to 5 C by 6 into C divided by 5C by 6 plus C. Okay. We have considered first two ones and then we have considered for the another two. So, C1, so C equivalent will be equal to C1 C2 upon C1 plus C2. So, from here I can say that 5C square by 6 divided by 11C by 6. It will be equals to C and C will get cancel out, 6 and 6. So, it will be equals to 5C by 11. Okay. From here I can calculate the charge. I can calculate the charge is equals to CV, that is 5C by 11 into volt. What will be the how much voltage is given? It's given as 55. So it will be equals to 5, right? C naught, C naught, C naught, C naught. So it will be equals to 25 C naught over here. Okay. Now we need to calculate the potential at two places. Here and here. Okay. Now my potential is here. So potential across these parallel values and these, it will be equal obviously. So at point B, at point B, it will be V is nothing but Q by C, right? So C is C naught and my charge and the charge between these plates will be equals to 25 C. So it will become 25 C naught. So it will be equals to 25 volt. Okay. Similarly, at point A, it will be equals to 30 volt. At point A, it will be equals to 30 volt by applying the that charge by applying that there will be no any a charge loss. Okay, so VA minus VB will be equals to 30 minus 25. It will be equals to 5 volt. Hence your answer is 5 volt here. Hence your answer will be 5 volt here. Again I am repeating this question. V naught is the potential across these, okay, and C equivalent we calculated to be 5 C naught by 11. Now after we calculate this, so the charge provided by the V naught, or we can say that the total charge will be equals to Q equals to CV, that will be equals to 25 C naught. Okay, and we know that charge cannot be destroyed nor be produced because charge is always conserved. Okay, so when I'm talking about VB, the potential at B, okay, while talking about the potential V naught, first it is going to the C naught and then that values. So from there I can say that potential at B will be equals to 25 C naught by C naught, it will be equals to 25 volt. VA will be equals to 30 volt. So VA minus VB will be equals to 30 minus 25 is equals to 5. Hence it is the answer. So much, and now all the questions are completed. Bye.
So hello everyone, my name is Pradeep, your chemistry master teacher, and I'm back with another discussion of full test 8th paper number 8. So let's start the discussion. The very first question is the most suitable method for separation of 1:1 mixture of ortho and para nitrophenols. All right. So we have been given ortho and para nitrophenols. So this one is ortho nitrophenol and this one is para nitrophenol. Okay. We have different options given over here. Question is which one to choose. Now, what method you are going to adopt for the separation of a mixture is going to depend on what are the differences in the properties of the components. Example, you'd use sublimation if you had the mixture of a compound, mixture of two components where one can easily be converted into the gas. So if one compound is quite volatile, another one is not, then you can use sublimation. Chromatography you use when there is a difference in the, good difference in the polarity of the two components, the way they behave with the mobile phase and the stationary phase. I hope you remember that. Crystallization, the same thing, differences in the solubility of the components. Steam distillation you use when there is a difference in the boiling point of the substances. The components that you have taken, if there is a difference in their boiling point, then you go for the steam distillation. Let's have a look at these two compounds. We know that in the orthonitrophenol, there is intramolecular hydrogen bonding. So there will be intramolecular hydrogen bonding in case of orthonitrophenol. On the other hand, there will be intermolecular hydrogen bonding through the hydrogen, of course, in the case of paranitrophenol. Right. So in the case of paranitrophenol, the two molecules or the molecules of paranitrophenol are going to be bonded together by hydrogen bonds. On the other hand, the hydrogen bonds of the orthonitrophenol are busy in the intramolecular hydrogen bonding. So, between two molecules of orthonitrophenol, you are not going to find the intermolecular hydrogen bonding, meaning two molecules or the molecules of orthonitроphenols are going to be weakly held together as compared to the molecules of paranitrophenols. In the case of paranitrophenols, there is a stronger intermolecular force of attraction which is missing in the case of orthonitrophenol. That becomes the very reason that boiling point of paranitrophenol become greater than boiling point of orthonitrophenol. The reason being the hydrogen bonding. Here you have the hydrogen bonding within the same molecule that is not helping the molecules to stay together closer, which is required to decide the boiling point. You understand that? In case of paranitrophenol, the hydrogen bonding is used to associate the molecules together strongly. That is the reason that boiling point is more here, less here. In fact, this is steam volatile. Now, you clearly see there's a difference in the boiling point. So the most appropriate method to separate these two is going to be steam distillation. I hope you understood this. Which method we are going to employ is simply going to depend on what are the differences in the properties of the components. Here, the difference in the properties that we are exploiting is the difference in the boiling point. I hope you understood this. Moving on to the next question. Question number 2 says, the major product in the following reaction. All right. So we have a ketoester given to us. Right. First, you are treating it with NaOET in presence of ethanol. So NaOET is essentially OET minus, which is a strong base. OET minus, we are treating it with the first reagent. When we are treating our substrate with the first reagent, in the first reagent we have NaOET in ethanol. From there, we are going to get ETO minus, the alkoxide ion, to be more precise, ethoxide ion. It's a strong base, we know that. Alkoxide ions are strong base. So if they are a strong base, it will be looking for acidic hydrogen. In the molecule, you see, here you got 2 hydrogen. The active methylene group, this active methylene group, the hydrogens over there are quite acidic because of these C double bond O group present on the adjacent positions. So this hydrogen being, the hydrogen attached to this carbon being most acidic is taken out, is extracted by the base here. This takes out the hydrogen. What will you be left with? Just remove the hydrogen and make the C minus over there, the conjugate base. All right. So C minus is formed. OET is attached over here. Let's not forget that. So when we treated our substrate with the first reagent, we are reaching at this point. Now, what are we taking next? We are taking ClCH2 whole 5Cl. All right. Meaning, if we expand the structure, we are seeing there are 5 CH2 like this. 1, 2, 3, 4, and 5. And the fifth one has a Cl. You see the alkyl halide. You see the R minus. You understand that why this hydrogen should be acidic, because the C minus formed over here is being stabilized in both the direction by resonance. That's the reason that methylene group, active methylene group, they have quite an acidic hydrogen. All right. So we have RX, alkyl halide, and here we have C minus. C minus, it's a very good nucleophile. Nucleophile, it sees the electrophilic center here. Nucleophile goes and attack on the electrophilic center. So there is going to be SN2 attack over here. So what is going to form? So let's write it on the next slide. Sorry for the inconvenience. Let's take it on the next slide. So we were left with this. Over here you had the minus charge, and then you had 5 carbon. So let's take 1, 2, 3, 4, 5. Fifth carbon has the Cl. First carbon also has the Cl. This is the same reagent. This is nothing new. This is ClCH2 whole 5 Cl in the expanded form. So you see 1, 2, 3, 4, 5 carbons. Each one is CH2 group, and the terminal carbons are attached with the chlorine. All right. So what is going to happen next? Nucleophilic attack, SN2 attack. This C minus is going to attack over here. Cl minus is going to leave. What are we going to see now? So this thing remains like this, and then on this carbon you understand is going to bond with this carbon from where the chlorine has left. So there is going to be one bond, and from here you are going to see 5 carbons. 1, 2, 3, 4, 5. Fifth carbon still got Cl. All right. So this is the scenario so far. When we treated it with ClCH2 whole 5Cl, we reached over here. All right. What's next? What else we are given with? After we treat with this, we once again take the strong base, which is the ETO minus. Once again, we are taking the strong base. So what is it going to do? It is going to do its normal job. Remove the most acidic hydrogen. If you watch it carefully, you still have one hydrogen remaining over there. This hydrogen will be quite acidic because the C minus which will form over here will be stabilized by the resonance over here. So the next step, ETO minus is going to come once again, trap this H plus and remove the H plus from here. What are we going to left with? We will make the conjugate base after removal of acidic hydrogen. So on this carbon, you are going to be left with a minus charge. Rest thing remains same, 1, 2, 3, 4, 5 carbons. So 1, 2, 3. Let's draw this once again. So 1, 2, 3, 4, 5. Fifth carbon got Cl. Why am I writing it like this? You'll understand it very soon. Right, all right. So we have reached over here. We haven't done any change in any other part. What we have done, just we took the strong base, it took away the acidic hydrogen, and we are left with C minus. I just wrote it in a particular way so that it's become easier for us to understand the next step. Let's not forget that this still has 5 carbons, right? C minus, within the same molecule, you are seeing the C minus. And within the same molecule, you are seeing the electrophilic center as well, the RX part. So carbon attached to the Cl is electrophilic. Within the same molecule, we have the nucleophilic part also. Here, you are going to see the intramolecular nucleophilic attack. Cl minus is going to leave. What are you going to see now? This carbon is now going to get bonded with this. A ring is going to form. So, to this part, that remains same. Nothing happens to that. C double bond O, C double bond O, OET. But this part is now going to get bonded with this carbon over here. If you see, this carbon here is going to bond with this carbon. So 1, 2, 3, 4, 5, and 6. 6-member ring is going to form over there. So let's make a 6-member ring over here, including the carbon over here. So this thing is going to form after the base attacked for the second time. When the base attacked for the second time, you understood what happened. Let's see once again. The base came once again, took away the acidic hydrogen, C minus formed. And here you see you have the electrophilic center. Within the same molecule, you have the nucleophilic site as well as the electrophilic site. So you are going to see the intramolecular nucleophilic attack over here. So this C minus formed over here is going to attack on this. So this will be bonding with this. That's what we have done over here, 6-member ring. All right. So far, till third reagent, we have reached there. What are we doing now? Next, we are taking it for the acidic hydrolysis, and then we are heating it. All right. So let's do the acidic hydrolysis for this. If you do the acidic hydrolysis, you understand that acid derivative, that part. How are you going to break this bond? So what you will simply do, you can simply imagine it like this. The water, OH and H, the H part is going to go with this, OH is going to go with this bond breaks, this bond breaks. What will you be left with? So we will be left with the ring on this carbon. This part remains the same, fine, this part remains the same, and then this part on the same carbon is going to convert into, this bond is going to break from here, it is going to get attached with the OH. This part converts into the carboxylic acid, and that part leaves as ETOH, ethanol. That part leaves as the ethanol. All right. What's next? We are heating it all as well. Do we remember this? That when you heat the beta keto carboxylic acid, meaning when there is a unsaturation, or when there is a carbonyl group, or when there is a keto group at the beta position of the carboxylic acid, then by simply heating it, carboxylic acid group leaves as CO2. We see this is the carbon, this is the COOH, all right? This is the first carbon from the COH group, so alpha, and on the beta position, you see the unsaturation. When you see the unsaturation on the beta position to the carboxylic acid, simply heating will remove the COH group as the CO2. So this thing is going to leave as the CO2, and what will you be left with? We will be left with the rest of the part. The rest of the part is on this carbon to left everything. On this carbon, you have two carbon, and on this carbon you are going to be left with C double bond O. So that is going to be our final product. I hope you understood this. So the final product is going to be this. Let's see which one does it correspond to. So this one is not this, obviously. This one is the correct answer. So the correct answer for question number 2 will be C. I hope you understood this. Moving on to next question. All right. Third question number 3 is from kinetics. So we have a reaction given to us. So 2N2O5, that gives us 4NO2 plus O2, all right? Given to us is the rate constant for the reaction is 2 into 10 raised power minus 5 per second. It's very important to focus on the unit over here. So the value of K which is given to us is 2 multiplied by 10 raised power minus 5 per second. Does this ring a bell? This must. Looking at the unit of K, you can tell that what is the order of the reaction. We clearly see K per unit time. When the unit of K is per unit time, that's nothing but the first order reaction. So it's a first order reaction. Directly by looking at the unit of K, we identified that. Fine. What else is given to us? At a given temperature, if the reaction is started with 10 moles per liter, all right. So we have the C given to us, which is 10 moles per liter of N2O5. Then the rate of formation of NO2 at the moment of the reaction when concentration of O2 become 2 mole per liter. All right. Let's see how to go ahead about this question. So at t equals to 0, let's write the information, what's given to us. At t equals to 0, we had 10 mole per liter given to us. Initially, they were not formed, so they were 0 and 0. The moment when you are observing the reaction, the moment at which you are going to observe this reaction, and what is that moment? That moment is that O2 formed is 2 moles per liter, all right. So we have the information given about O2 at the required time, at whatever moment we need to find the rate of formation of NO2. At that moment only, the concentration of O2 is 2 moles per liter. So let's write that. So we got 2 moles per liter of O2 formed. Now let's think just a little. How is it possible that 2 moles per liter was formed? So simple stoichiometry we need to use over here. We see when 2 mole per liter of N2O5 reacts, 1 mole per liter of O2 will form. Simple stoichiometry I'm applying over here. When 2 mole per liter of N2O5 reacts, in that case, 1 mole per liter of O2 should form. All right. How much is formed? 2 mole per liter. So if 2 mole per liter of O2 is formed, that obviously means 4 moles per liter. There is a little space crunch over here. I will write it over here. So when O2 formed is 2 moles per liter, in that case, the N2O5 reacted, the amount which reacted must be 1 requires 2, so 2 would require 4 moles per liter. So 4 moles per liter of N2O5 must have reacted so far. So how much must be remaining? You had 10, out of 10, 4 has reacted, so the amount remaining is going to be 6 moles per liter. That much mole. That is the concentration of N2O5 when the concentration of O2 formed is 2 moles per liter. All right. At this moment itself, you need to tell what is the rate of formation of NO2. All right. How can we write the rate of formation of NO2? Rate of formation of NO2. Should that be change in the concentration of NO2 divided by the time? This is the rate of formation of NO2. How is it related to the rate of reaction? So we know how to write the rate of reaction in terms of rate of disappearance of the reactant or rate of appearance of the product. It's simply rate of formation of the product, since we are dealing with the product right now at this moment. So let's write it. Rate of formation of NO2 divided by or multiplied by 1 by stoichiometric coefficient of that particular product. Once again, rate of reaction will be equal to rate of formation of NO2 divided by 4. That we understood. That we know from the kinetics, how to write the rate of the reaction in terms of the rate of disappearance of the reactant or the product. Just for a quick recap, if you have any reaction giving you A plus B gives us C plus D, let us say the stoichiometric coefficients over here are X, Y, M, and N. How do we write the rate of reaction? Rate of reaction is going to be 1 upon X with the minus sign, because for the reactants, you write with the minus, because that is the change in the concentration of reactant will be negative, final minus initial. So negative minus negative, we need to make that positive. Rate is a positive term. So minus of, when you are dealing with the reactant, use minus, and then change in the concentration of A by delta T. This term is nothing but rate of disappearance of A. All right. If you want to write the rate of reaction in terms of B, that will be, once again, that's a reactant. So we are going to use a minus sign into 1 by Y, the stoichiometric coefficient, into change of concentration of B divided by delta T. Now, this term is rate of disappearance of B. If you divide the rate of disappearance of B by its stoichiometric coefficient, it becomes the rate of the reaction. You can write it in terms of the rate of formation of C as well. So, what will it be? 1 by stoichiometric coefficient of the product you are dealing with, multiplied by change in the concentration of C by delta T. Now, this is the term you call the rate of formation of C. If you want to write the rate in terms of D, same thing. 1 by stoichiometric coefficient of that product, multiplied by change in the concentration of D by delta T. This is the rate of formation of D. We have used the same concept to solve the previous question. So rate of formation of NO2 can be written as change in the concentration of NO2 by delta T. When you divide the rate of formation of product by its stoichiometric coefficient, that becomes the rate of the reaction. But it's a first order reaction. How do we write the first order reaction? Rate of the first order reaction, will it be the rate constant multiplied by the concentration of reactant, which is nothing but N2O5 raised to the power order with respect to N2O5, and we clearly know it's 1. Order is 1. So raised to the power 1. All right. This is equation 1. This is the expression for the rate. This is also the expression for the rate. So at given moment, equation 1 must be equal to equation 2. Let's equate these two equations. What do we get? So taking it on the next slide. So we see that K into concentration of N2O5 at given moment gives you the rate of reaction at that moment itself, equals to 1 by 4 into rate of formation of NO2. All right. Rate of formation of NO2 at the moment when O2, concentration of O2 was 2 mole per liter. So the concentration of O2, when that was 2 mole per liter, at the same moment, the concentration of N2O5, we have calculated that from the table, that it came out to be 6 moles per liter. So when this is the concentration, what is the rate? Let's put this value over here. K value is already mentioned to us in the question. The value of K is 2 into 10 raised to the power minus 5. So let's put all the values here. 2 multiplied by 10 raised to the power minus 5 multiplied by concentration of N2O5. That came out to be 6 moles per liter. That should be equal to 1 by 4 into rate of formation of NO2. Let's just solve this. We will get the answer for this. So solving this, what do we see? What do we get? So this is 12 multiplied by 4. So 48 multiplied by 10 raised to the power minus 5. That will be equal to the rate of formation of NO2. So let's see which option tells us the same. So we got 48 multiplied by 10 raised to the power minus 5. Okay. So if you convert it, if you take the decimal on the left-hand side, it will be 4.8 into 10 to the power minus 4, which corresponds to option B. I hope you understood this. A very simple question from the kinetics. But here in this question, you need to have the clarity about what are the different ways how different ways to write the rate expression for a given reaction. I hope you understood this. Moving on to the next question. Question number 4. All right, sorry. Question number 4. This question is from Electrochemistry. Let's see what information we have with us. So we have the conductance of 0.018 molar aqueous solution of a weak monobasic acid. So let us assume that the weak monobasic acid is going to be HA. Monobasic acid means the one which can give you only one H plus. So this is the weak monobasic acid, let's say. Okay. Concentration of this is given to you. So let's write concentration. It's 0.0018 molar, or for our own convenience, we can also write it as 1.8 into 10 raised to the power minus 3 molar. Fine. So this is the concentration of, initial concentration of HA given to us. Okay. So the conductance was determined by using a conductivity cell consisting of platinized platinum electrodes. The distance between the electrodes is 200 centimeter. All right. So L is given to us 200 centimeter, the distance between two electrodes. And centimeters. So yes, good to go with. This is the unit we need for the distance. An area of cross section of 2 centimeters square. So we don't have to worry about the units over here. They already have given us the favorable units, the unit that we are going to use for the calculation. The conductance was found to be 3 multiplied by 10 raised to minus 7 Siemens. All right. So G value is given to us. 3 multiplied by 10 raised to minus 7. All right. And then they mention the pOH of the solution is 10. Okay. So pOH value is mentioned to us. It's 10. The value of limiting molar conductivity. Okay. So limiting molar conductivity we need to find for this monobasic acid in the aqueous solution. Okay. How to think about this question? So first thing that should come to our mind is that what are the approach to calculate this? So when you want to calculate the limiting molar conductivity, you can use either this formula. This I have taken from this, that alpha of the electrolyte given to you will be the ratio of molar conductivity at C divided by concentration C and the limiting molar conductivity. So I have used this formula. Either you use this or you calculate it using the another formula, which is K multiplied by 1000 divided by solubility. Now, in order to know the solubility, you will have to get into the details of the KSP and all. So this formula, this approach will become a little hectic for us. So it's better that we focus on calculating these two. If we somehow find the molar conductivity and the alpha, we will be able to get the answer for this. Okay. How to get the molar conductivity at concentration C? For this, we have a simple formula, that is K multiplied by 1000 divided by concentration. Do we know K? Yes, we know K. K value is not given to us directly, but we have a way to calculate K. How do we have this? We know K equals to cell constant L by A multiplied by the conductance. This is how you can calculate the value of K. Do we know the value of L? Yes, we know. Let's put the values. That's 200 centimeter divided by area. It's given to us 2 centimeters square, so we don't have to worry about the units over here. You understand? Multiplied by G. G is given to us 3 multiplied by 10 raised to power minus 7. Let's do the calculation. So this is going to be 100. 3 multiplied by 10 raised to power 2, 10 raised to power minus 7. All right, 10 raised to power minus 5. So the value of K is going to be 3 multiplied by 10 raised to the power minus 5. All right. So we are done with this. Do we know the C as well? Yes, it's given to us. The C value is given to us, this value. So let's calculate lambda C, the molar conductivity at concentration C. Will it be equal to the value of K, which is 3 multiplied by 10 raised to the power minus 5, divided by, all right, multiplied by 1000 as well, divided by concentration, which is 1.8 into 10 raised to the power minus 3. Let's do the calculation. What do we see? We are going to get 3 by 1.8 multiplied by, this is 6, 10 raised to the power 1, so basically 10. We are not solving it at this moment. We'll see. Let's not do all the calculation in each and every step. Let's keep few calculations for the end. Wherever you feel that the calculations are going to be a little complicated, you can keep it for the end. There is a very good chance that they might cancel out. So that may save us some time. So this is the molar conductivity at concentration C. We got this. Meaning we are one step closer to find this. We have found this. How to go ahead about alpha now? So if you want to consider alpha, you will have to consider the dissociation of the weak monobasic acid. So let's consider that and see what we get. So HA, which is a weak acid, it will dissociate partially into H plus and A minus. All right. At T equals to 0, let us say the initial concentration is C, and you know C equals 1.8 into 10 to the power minus 3 molar, that's given to us. Okay. Initially, you didn't had any of these, so 0 and 0. When the equilibrium is attained, at that moment, you will be left with C minus C alpha. This will be C alpha, and this will be C alpha. I have simply used the stoichiometry to get this table. When 1 mole dissociates, you get 1 mole of H plus. So this is the amount which dissociated. So if C alpha dissociate, you are going to get the C alpha moles of concentration of H plus. When 1 mole of HA dissociates, you get 1 mole of A minus, or when 1 molar HA dissociate, you get 1 molar A minus. Same way, if C alpha molar concentration, if that dissociates, you are going to get C alpha molar of A minus. All right. In the problem, they have mentioned the value of POH. And the value of POH that they have mentioned is 10. All right. So value of POH is 10. Meaning the value of pH is going to be 14 minus POH equals to 10, because we know pH plus POH equals to 14 for a given solution. All right. So pH we got as 4. Now, how pH is helping us to solve this problem? It is helping us. How? See, once we get the pH as 4, we know the concentration of H plus. Will the concentration of H plus, is that equal to 10 raised to the power minus of pH? Why did I say so? It's because pH is defined as minus log of concentration of H plus. Applying the simple maths here, you can say that concentration of H plus is going to be 10 raised to the power minus of pH. All right. So we got the concentration of H plus. We know the pH. Let's put the values. What do we get? The value of pH is 4. So the concentration of H plus is going to be 10 raised to the power minus 4 molar, of course. That's the concentration. So we got the concentration of H plus in the solution. Now, how is it helping us to solve the problem? It is helping us because concentration of H plus should be C alpha. And the pH is telling you that this should be this. It's the same solution you are talking about. That means this must be equal to C alpha, which I took from here. C is mentioned to us. Look at this. This is already known to us. This is the only one unknown. One equation, one unknown. We surely can find the value of alpha from here. Let's find it. Will the alpha be 10 raised to the power minus 4 divided by C? I am using this. Let's put the values. 10 raised to the power minus 4 divided by the concentration, which is 1.8 into 10 raised to the power minus 3. Solving this, we are going to see 1 by 1.8 multiplied by, this is 10 to, this will be 10 raised to the power minus 1. All right. So this is the value of alpha we got. And from the last slide, we got the value of molar conductivity at concentration C, which is 3 by 1.8 into 10. All right. So let's write it over here together. So molar conductivity at concentration was 3 by 1.8 multiplied by 10. Okay. We are supposed to find the limiting molar conductivity. So let's use the formula. Limiting molar conductivity, is that going to be the molar conductivity at concentration C, which is 3 by 1.8 into 10 divided by alpha, which is 1 by 1.8 multiplied by 10 raised to the power minus 1. Let's just solve this. You see that 1.8 will get cancelled out. You will be left with, this goes up, 100 multiplied by 3. You are going to see the answer as 300. I hope you understood this. And you also saw the advantage of not calculating the complicated calculations at these points. Here you see they got cancelled out. So that's the reason that whenever you feel that the calculation is going to be little lengthier or little complicated, just leave it for the last step. So we got the value of limiting molar conductivity as 300. Let's see which option corresponds to this. 300 Siemens centimeter square per mole. So option C will be the correct answer for question number 2. I hope you understood this. A very good question. Moving on to next question, which is question number 5. The major product of the following reaction will be this. Okay, let's focus on the details, what we have over here. So we have the benzene, all right. And with benzene, we have this ketone given to us. Okay, one information which you must not miss is that this is in excess. All right. This with the acid, H2SO4, acid is going to give you H+. Okay, so what H+ is going to do? H+ is just going to find the basic site and go and attack on the basic site, that's all. We know that oxygen over here is basic, so this accepts the H+. So if this accepts, this is going to become OH, this is going to accept H+, and this is going to become this. Oxygen will develop a positive charge. All right. In order to neutralize this positive charge, this electron moves like that. What are you going to be left with? You are going to be left with OH, and carbon will have the positive charge. Well, what happened over here? You have an electrophile generated. Whenever you see the benzene with some reagent taken, understand that 95% of the time, the reaction is going to be electrophilic aromatic substitution only. Meaning, from the other part, you must be generating the electrophile. And you can clearly see that's what happened over here. The other part, other than benzene, they reacted together to produce an electrophile. As soon as you have an electrophile is going to attack on the benzene ring. That's the electrophilic aromatic substitution reaction, we know that. So what is the product forming over here? Let's take it on the next slide. So we have this benzene ring, and we have an electrophile generated over here, which is this. Benzene ring is going to attract this electrophile. Electrophile is going to attack on this benzene ring, and the product that you are going to get will be, this is going to attach from the electrophilic carbon. So this carbon, it attached. You have 1 and 2 methyl groups attached with one OH group. All right. So we got this after the first attack of the electrophile. All right. But let's not forget that this was in excess. So we have many benzene rings still unreacted over there. We have some acid as well over there. So acid will do its usual job once again. It's going to find the basic site in the molecule. We can clearly see that oxygen once again is basic. So this is going to accept the H+, and if it accepts the H+, what is it going to become? This is going to become this OH2. OH it already was, one more hydrogen, so OH2 plus. Now you understand that OH has converted into a very good leaving group, H2O. So this is going to leave now. If this leaves, meaning water leaves, are we going to see this benzene ring attached with a carbocation? You see, this left. So there is going to be a positive charge on this carbon. So we have electrophile, all right. And we have unreacted benzene ring as well in the container. Why do we have it still remaining in the container? Because we took that in excess. So electrophile, benzene ring, you don't have to think anything but electrophilic aromatic substitution. Simply think ES. Let's take the electrophilic attack on this benzene ring. Of course, this has to happen from the electrophilic carbon itself here. And you're not going to think about the rearrangement of this C+. You understand why? One thing, that's 3 degree. Another thing, that is resostabilized. So you're not going to rearrange this positive charge from here. All right, let's take the attack on this ring. What are we going to get? This remains like this. I'm drawing the first benzene ring with its group. This carbon is going to bond with another benzene as well. So let's bond it with another benzene. This and this carbon itself has 2 methyl group as well. So let's attach that, and this will be your final product. I hope you understood this. Now, this is going to be a final product. You don't have any basic site, so you're not going to see the further generation of the electrophiles. So that's why the reaction is going to stop here at this point. So this is going to be the final product. Let us see which option corresponds to this, not this, not this. This is the correct answer. I hope you understood this. Moving on to the next question, question number 6. Given below are 2 statements. All right, potassium permanganate on heating at 573 Kelvin forms potassium magnate. That's correct. If you take potassium permanganate and if you heat it, you are going to see K2MnO4 plus MnO2. So you'll be seeing potassium permanganate forming, potassium manganate forming over here. Potassium manganate forms over here. All right. This is potassium permanganate. This is potassium permanganate. All right. So the first one is true, of course, that when you take the potassium permanganate, when you heat it, it is going to form the potassium manganate, the MnO2 and the oxygen. All right. Statement 2 says, so statement 1 is of course correct. Statement 2 says that both potassium permanganate and potassium manganate are tetrahedral. Let's check the geometry first. MnO4 minus, this indeed is a tetrahedral geometry. Mn attached with 4 oxygen like this. So this has a tetrahedral geometry, that's correct. Which is the MnO4 minus 2. MnO4 minus 2, this is your manganate ion. Let's draw the structure of that and see what do we get. This is also tetrahedral geometry. So MnO4 minus 2, this also has a tetrahedral geometry. You can clearly see the hybridization. Based on the hybridization, you can clearly say that the geometry of the MnO4 minus 2 and MnO4 minus both are going to be tetrahedral only. All right. sp3 hybridization. Let's see. So the first thing, the first part of the second statement that they are saying that tetrahedral, yes, that's correct. And they are saying that both are paramagnetic in nature. Now that's where they went wrong. When you take MnO4 minus, this is minus, permanganate ion. MnO4 minus, when you take this, over here, manganese is in the +7 state. This doesn't have any unpaired electron, no unpaired electron left. Since this doesn't have any unpaired electron, this is diamagnetic in nature. So, Mn plus 7, if you write the configuration, you will find 4s0, 3d0. No unpaired electron. This manganese doesn't have any unpaired electron over here, so that's why this is diamagnetic in nature. On the other hand, if you check this, manganese over here is in the plus 6 state. Mn plus 6, you will find the configuration is 3d1. This has one unpaired electron over there. That's why this one is paramagnetic, but this one was diamagnetic. On the other hand, in the statement 2, it says that both are paramagnetic, which obviously makes it wrong. So statement 1 is true, but statement 2 is not true. That's false. So statement 1 true, but statement 2 is false. So A will be the correct answer. I hope you understood this. You understand that KMnO4, when you heat it, it gives the potassium manganate, MnO2, and also O2 is produced. You understood the geometry. You understood the magnetic nature of the compounds. I hope you understood this. Moving on to the next question. Question number 7. All right. So we have 0.1 mole of CH3NH2. Kb value is given to us. It's mixed with 0.08 mole of acid. So first, let's write what we have given. So we have CH3NH2. This given to us. We have Kb value of this given to us, which is 5 into 10 raised to power minus 4. You understand from this data that it's a weak base. Why is it a base? It's because nitrogen got the lone pairs. All right. So this is a probable potential H plus acceptor. All right. What else we have over here? We have the moles of this given to us, which is 0.1 mole. All right. And now you are mixing this with HCl. Okay, what information we had about the HCl? So we have the moles of HCl given to us 0.08. This is a strong acid. K value is not mentioned. That is the one trick that you usually apply in the problems of the ionic equilibrium. By the way, you already know HCl is a strong acid. All right. So we have taken a strong acid. We have taken it with the weak base. And then when we mix them, then we dilute to 1 liter. Let's understand the problem. What is it given to us? So you got a container, right? In this container, you have CH3NH2, all right. The moles of this is given to you 0.1. And you are mixing HCl in the same container, all right? So we have the HCl mixing in the same container. The moles of this is 0.08. Okay, after you mixed it, once you have mixed it, then you are adding water to it so that volume of solution become equals to 1 liter. This is the problem given to us. All right. Question that is being asked to us is that what will be the H plus concentration in the solution? So if you want to find the H plus concentration in the solution, first we need to understand that what happens, what are the things remaining in the solution, because they only will be deciding how many H plus or OH minus remains in the solution. So if nothing comes to our mind, one thing we know, we have mixed an acid and a weak base, whether it's a weak base or strong base. If you have taken it with another acid, there will be complete neutralization as long as you have the required amount present. If you have the required amount present, there will be complete conjunction of the acid and base. What do I mean by the required amount? I mean to say stoichiometric amount or equal equivalence. So let's not think anything, but take the acid-base reaction first and let's see what remains in the solution. Because you have mixed base with the acid, so there is going to be a neutralization reaction. Let's take that reaction. Let's see what we get. So we have CH3NH2. All right. We understand that it's a base. Okay. We have taken it with the HCl. Let's take the reaction. This will be donating the H plus. This will be accepting the H plus because of the lone pair on this. So this thing converts into CH3. Now it will have 3 hydrogen and nitrogen will have a positive charge, NH3 plus. Then Cl minus from here will combine with this. Basically, this salt will be formed. All right. Acid-base reaction doesn't matter. That's a weak or strong base. That doesn't matter. As long as you are having the stoichiometric amounts present, they will react completely. All right. Let us see here what information we have here. So we had 0.1 moles at T equals to 0. We had 0.1 mole. These are the moles given to us, not the concentration. So let's stay focused. HCl given to us was 0.08 mole. Initially, this was not formed. All right. When the reaction completes, when the reaction is over, who will be remaining or who reacted how much, that we can simply decide by the stoichiometry. This is a balanced equation if you see. 1 mole of HCl reacts with 1 mole of the CH3NH2. You have 0.08 moles of HCl. If you have 0.08 moles, that will react. 1 reacts with 1. So 0.08 and this is 0.1. You see that this is the limiting reagent. That will react completely. So you are not going to have any amount of HCl remaining. 0.08 reacted completely. Why? Because that's the limiting reagent. Okay. 1 reacts with 1. So 0.08 must have reacted with 0.08 moles of CH3NH2. How much will be remaining? 0.1 minus 0.08, meaning 0.02 moles. These are the moles. Let's not forget that. This much will be remaining. 0.08 has reacted and you are left with 0.02 moles of CH3NH2. All right. So HCl consumed completely. Not a problem. How about this salt? How much will this be forming? So when 1 mole of this reacts completely, 1 mole of this is formed. 0.08 reacted completely. So 0.08 moles will be forming. Right. So ultimately, when you mix these two, ultimately you will be left with the weak base with its salt with strong acid. Does that ring a bell? What kind of problem we are going to deal with? We will be left with a weak base and its conjugate acid, or you can simply say it's salt with strong acid. So in this container, we are going to be left with, which has the volume of 1 liter, you will be left with CH3NH2. How much amount will be remaining? The remaining amount is going to be 0.02 moles. And this salt, CH3NH3 plus Cl minus, the amount of which, the moles of which is 0.08. The mixture of a strong base, weak base with its conjugate acid. Or you can say the mixture of weak base with its salt with strong acid. That is nothing but a basic buffer problem. This is a basic buffer problem now. So these two are remaining in the container. They will be deciding what will be the pH of the solution or the concentration of H+. So whenever you are dealing with the buffer solution, one equation that directly comes to our mind is Henderson's equation. So you can solve it using the Henderson's equations also, or you can simply take the action of this base with the water. But before we move ahead, we will be needing the concentration of the base and of the salt. These are the moles remaining in the 1 liter solution. So can I say that concentration of CH3NH2 remaining in the container is 0.02, that many moles in 1 liter. That means this is the molarity of CH3NH2 remaining after the reaction with HCl, and the concentration of the salt, that is going to be equal to its mole in the solution divided by volume of solution in the liters. That will be 0.08 moles per liter. All right. So we know the concentration of the base. We know the concentration of the conjugate acid, or say the salt over here. Salt and the conjugate acid has 1:1 stoichiometric ratio. Not going to that. You already understand that? this 1 mole of this will break to give you 1 mole of the conjugate acid. So whatever is the concentration of salt in this case, same is going to be the concentration of conjugate acid. All right. Let's see. Kb value is already mentioned to us. See, from here you can directly apply the Henderson's equation. If you apply the Henderson's equation, which says that POH will be equal to pKb plus log of concentration of conjugate acid. In this case, 1 molar conjugate acid will 1 molar salt will give you 1 molar conjugate acid, or whatever is the concentration of the salt, same will be the concentration of conjugate acid, divided by concentration of the base. Let's put the values and get the answer. The value of pKb is given to us in the question. It is 5 multiplied by 10 raised to the power minus 5. Let's put it over here. So this is minus of pKb is minus log of kb. So let's put the values. Log of kb, which is 5 into 10 raised to the power minus 4, plus let's put the concentration of the salt as 0.08 divided by concentration of base 0.02. All right. Let's solve this. Minus, I'm keeping this in the bracket. Will it be log of 5, applying the property of log of A into B equals to log of A plus log of B, plus log of 10 raised to the power minus 4. Log of 10 raised to the power minus 4 is going to give you minus 4. All right. Plus log of 8 by 2 means log of 4. All right. Let's solve this. Minus log 5 value is 0.7. Opening the bracket. Minus and minus plus 4. Plus log 4. Log 4 is 0.6. If you solve this, what are we going to see? 4, this one is going to be minus 0.1 equals to 3.9. So POH is going to be 3.9. This is one of the method. After this, I will tell you the another method as well, by which you can easily get the answer. So POH comes out to be 3 raised to the power minus 9. So pH will be 14 minus POH, which is 3.9. That comes out to be 10.1. So 10.1 will be the value of pH. Once we know the value of pH, we know that concentration of H plus is equal to 10 raised to the power minus pH, or let's put the value. This is what we are asked in the problem. We need to find the concentration of H plus. Taking the values over here, 10 raised to the power minus 10 raised to the power 10.1. How to solve this? You can write it as 10 raised to the power minus 10 multiplied by 10 raised to the power minus 0.1. If you take this value, this is this. If you solve this, this is going to be taking the antilog. This is going to give you 0.8. So this is 0.79 something, but that will come out to be 0.8. Get the answer. Concentration of H plus will be, writing it in the form of moving the decimal on the right hand side, it will become 8 multiplied by 10 raised to the power minus 11 molar, or say moles per liter. That will be our answer for this question. That is directly from the Henderson's equation. That is one of the way. Because when we are dealing with the buffer solution, the one formula that comes to our mind directly is the Henderson's equations. Using that, you can solve this. There is another way as well to get to solve this question, which is the CH3NH2 in the solution. This is method number 2, another way. So you have CH3NH2 remaining in the container, and then you have CH3NH3Cl, the salt remaining in the container. Concentration of this is given to us 0.08. This is the concentration for this given. And the concentration of this is 0.02. That much is remaining in the same container. All right. This being a base will react with the water. This will accept the H plus from the water and will give you CH3NH3 plus. All right. There will be an equilibrium sign over here. This is a weak base. NH3 plus, and the remaining part will be OH minus. This is a salt. Any salt is a strong electrolyte. So that is going to dissociate 100% in the aqueous solution. So this will dissociate as CH3NH3 plus plus Cl minus. All right. When 1 mole dissociates, you get 1 mole of this. When 0.08 mole dissociates, you are going to get 0.08 mole per liter of this conjugate base. Once again, this is the molarity concentration. 1 molar solution dissociates, you get 1 mole of this. 0.08 molar dissociates, you'll get 0.08 molar of this. All right. When you look at this equilibrium, this is happening in the same container. You see, this will be applying a common ion effect on this. Because of the common ion effect, the alpha of this equilibrium is going to get suppressed further. This is producing a common ion over here, you understand? So majorly, this CH3NH3 plus at T equals to 0, you had 0.02 molar. This is already present in the solution from the salt, 0.08 molar. This is 0 at this moment. All right. When the equilibrium is attained, you will be left with 0.02 minus 0.02 alpha. C minus C alpha will be remaining here. How much will this be forming? So this will be 0.08 from here, from the salt, plus the amount that was produced by the base, 0.02 alpha. This will be 0.02 alpha. All right. Here, you can do this. You can ignore the concentration of this coming from the base. You can take the approximation as well. You can write the expression of Kb. When you write the expression of Kb and take the approximation that alpha is lesser than 1, I will show you it over here. That Kb value, can you always write it as concentration of those two multiplied. So concentration of CH3NH3 plus multiplied by concentration of OH minus divided by concentration of this CH3NH2. If you put the values, what do we see? This one comes out to be 0.08 plus 2 alpha, 0.08 plus, 0.02 alpha, multiplied by concentration of OH minus, which is 0.02 alpha, divided by concentration of this, which is 0.02, let's taking 0.02 as common, 1 minus alpha. You understand the importance of taking approximation in ionic equilibrium. If you take approximation, that saves you from lots of calculation. So let us approximate that alpha value is far lesser than 1, negligible, meaning we are going to approximate that 1 minus alpha is going to be approximately 1, or 1 plus alpha is going to be approximately equal to 1. Of course, this is not just any random approximation that we are taking. You need to validate that later. Whatever value of alpha you are going to get, that alpha value must be lesser than 0.05. If the value of alpha that you get is lesser than this, then only your approximation was correct, else it's wrong. You will have to solve the quadratic. You understand that? So taking the approximation, put the value of Kb, that is given to us as 5 multiplied by 10 raised to the power minus 4. Yes. So putting the value over here, Kb value, 5 multiplied by 10 raised to the power minus 4 equals to, we have ignored this. From here, you can take the 0.02 as common. You will be seeing 0.02. This will be 4 plus alpha into 0.02 alpha divided by 0.02. This and this gets cancelled out. If you ignored alpha with respect to 1, you can surely ignore alpha with respect to 4. So this thing comes out to be 5 multiplied by 10 raised to the power minus 4 equals to 4 plus alpha we ignore to become equal to 4, and then the concentration of OH minus was 0.02. When you solve alpha, you will find the value of alpha, that will be 5 into 10 raised to the power minus 4 divided by 4 into 2, 0.02 into 10 raised to the power minus 2, we can write it like that. So this is going to be 5 by 8 multiplied by, this is going to be 10 raised to the power minus 2. You see that this value is lesser than 0.05. That means our approximation was correct. If approximation is correct, that means that would mean that concentration of CH3NH3 plus Cl minus, which is equal to 0.08 plus 0.02 alpha that we got from the table, we can simply ignore this. You can check that also. Just put the value of alpha. You'll find this value is quite lesser with respect to this. So that's why whenever you are dealing with the buffer solution, take the concentration of the conjugate acid majorly from the salt itself. You don't need to consider 0.02 alpha, meaning the concentration of conjugate acid, the CS3 and not Cl minus, CS3 NH3 plus. That ion mainly from the salt you have to take. So that's why we'll write it as equal to the concentration of salt. Based on that, we see a formula for this CH3NH2. The amount of this was 0.02. All right. This with the water, this gives us CH3NH3 plus OH minus. You can write the expression of Kb for this directly. Will it be concentration of CH3NH3 plus into concentration of OH minus divided by concentration of CH3NH2 remaining at equilibrium? All these concentrations should be at equilibrium. All right. Putting the values over here, Kb value is 5 into 10 to the power minus 4. Now see how easy the problem becomes once you are sorted that what are the concentrations at the equilibrium. I told you that this concentration should be taken only from the salt. You can ignore this ion coming from the base. So this thing was 0.08. All right. Multiplied by concentration of OH minus divided by concentration of CH3NH2. Concentration of CH3NH2 remaining was 0.02 only. It should be 0.02 minus 0.02 alpha, but you understand that we have ignored that. Alpha is very, very less. Basically, concentration of the salt divided by concentration of the base that was remaining in the container. All right. From here, you can directly solve the concentration of OH minus. This thing is 4. This will come out to be 5 divided by 4 multiplied by 10 to the power minus 4. So that is the concentration. That is the concentration of OH minus. In any solution, we know that concentration of H plus multiplied by concentration of OH minus is equal to 10 to the power minus 14. So concentration of H plus will be 10 to the power minus 14 divided by concentration of OH minus, which is 5 by 4 into this. So 5 by 4 multiplied by 10 to the power minus 4. Solving this, what do we get? 4 goes up. 4 by 5 multiplied by 10 raised to the power minus 10. Solving this, we see 0.8 multiplied by 10 to the power minus 10, or it will ultimately come out to be 8 multiplied by 10 to the power minus 11, and that will be our answer for the question. I hope you understood both the methods. The Henderson's equation is a normal approach. That will be the natural tendency. That Henderson equation will naturally come to your mind, of course. But this was just to show you that there is another method as well to solve for the concentration of H plus. So the correct answer for this will be B. We got this. I hope you understood this. Moving on to question number 8. All right. Which of the following statement is wrong? The stability of hydrides increases from NH3 to BiH3 in group 15 of the periodic table. This itself is wrong. You understand that as you go down the group from nitrogen to bismuth. So as you go down the group, the bond strength decreases. The extent of overlapping decreases. The bond becomes weaker and weaker as you go down the group. So the bond is becoming lesser and lesser stable. Thermal stability is decreasing down the group. So the first statement itself is wrong. So this should be the correct answer directly. But let's check the another one also, another options also. Nitrogen cannot form d pi p pi bond. Yes, correct, because there is no d orbital in the nitrogen. Single NN bond is weaker than the single PP bond. That is also correct. Nitrogen single bond and phosphorus single bond. You understand that nitrogen being smaller in size and lone pairs on both the atoms. Phosphorus is bigger in size and lone pairs on the phosphorus atoms. The lone pairs are closer in case of nitrogen atoms. So because of lone pair repulsion, the bond becomes weaker, and that repulsion is lesser over here in the case of phosphorus because of its bigger size. Lone pairs are at relatively greater distance, more dispersed. So nitrogen single bond, of course, is weaker than the single phosphorus bond because of the lone pair repulsion that once again arises because of the small size of the nitrogen. All right. N2O4 has nitrogen bond. That's correct. That's nothing but the dimer of NO2. So this, you see that you have nitrogen single bond over there. So the wrong statement is option A. I hope you understood this. Moving on to question number 9. Which of the following molecules are chiral? All right, they're asking about the chirality of the molecule. So if you want to check whether a molecule is chiral or not, just see if the elements of symmetry are absent or not. More specifically, you don't need to check all, just check plane of symmetry and center of symmetry. If both of these two are absent from the molecule, in that case, the molecule become chiral. Let's check each one of them over here. So the first one, doesn't matter from where you pass center of symmetry, that you can never have in the 3-member ring. Do you understand that? Correct? So center of symmetry is obviously absent. Plane of symmetry, if you pass any plane, like let's say pass from here, anywhere, you are not going to see any plane of symmetry in this. The plane of symmetry, you understand that is going to divide the molecules into 2 equal halves. So doesn't matter from where you pass the plane in this molecule, you are not going to see any plane of symmetry. So in this, COS is absent, POS is absent. That's why 1 will be our chiral molecule. Option 2, let's draw it here and check this. So you have one molecule coming out, one methyl group coming out of the plane, and another methyl group going out of the plane. This has a plane of symmetry. How? Just pass a plane crossing, which is going through both the methyl group. Pass through this. Over here, the groups will be cut into halves. Over here, the groups will be cut into halves, equal parts. This part will be cut into half. This part will be cut into the half. That too, the equal halves. So here, if you pass a plane through this, passing through these methyl group over here, that will divide the molecule into 2 equal halves. Since this has a POS, that's why this is not a chiral molecule. Same thing happens in the option C also. Look at this. This methyl group is coming like this outside, and that methyl group is going behind the board. If you pass a plane passing through this methyl group here and this methyl group over there, that will divide the molecule into 2 equal halves. That means this has the POS. That's why option 3, question third one, is also not chiral. That's not chiral. Question number 4. Question number 4, you see that this is one ring, another ring. Okay. So this another ring is not in the plane, in the same plane of this ring. You clearly see that this ring is coming like this. This ring is in the plane of the board. This ring is like this. Now, doesn't matter from where you try to pass the plane, you will never get the plane of symmetry. So plane of symmetry is absent. Center of symmetry will also be absent. That's why question number 4 will also be chiral. So correct answer for this will be 1 and 4. I hope you understood this. Very simple. But if you want to master isomerism, you should understand about the geometry really well. The geometry of the groups and your visualization. You should, once you are clear with the geometry, then only you will be able to visualize the molecules, how the molecules are getting divided into equal halves or not equal halves. That is possible only if you are clear, if you are clear with the geometry of the molecule. I hope you understood this. Moving on to the next question, question number 10. So the equilibrium constant for the reaction A in equilibrium with B that is given to us. All right, equilibrium constant is given to us. That is 2 multiplied by 10 to the power 3. Fine. The forward rate constant in the presence and absence of catalyst. All right. So once we took this reaction in presence of catalyst, then the Kf, the rate constant for the forward direction in presence of catalyst, C stands for the catalyst over here, that was found to be 5 multiplied by 10 to the power 4 per second. And when you took the same reaction in absence of catalyst, the Kf was found to be 4 into 10 to the power minus 6 per second. Just to be clear over here, equilibrium constant for a reaction is not impacted, is not affected, that value is not affected by the catalyst. Whether you take the catalyst or do not take the catalyst, K equilibrium of a given reaction at given condition is going to remain constant. All right. The expected rate constant for the reverse reaction in the absence of catalyst. Let's focus on this word absence. We know that K equilibrium equals to rate constant for the forward direction divided by rate constant for the backward direction. Whether you take the catalyst or not, K equilibrium value is not going to change. All right. So if you are taking in absence of catalyst, so this value, the two values are taken under the same condition. It's not like the Kf should be corresponding to the catalyst or Kb should be in absence of catalyst. Not like that. You have to take the ratio, the Kf and Kb, measured under the same condition. So if this was in absence of catalyst, this should also be in absence of catalyst. If this was in presence of catalyst, this should also be in presence of catalyst. All right. The question that they ask us is that we have to calculate the Kb for the reaction. Rate constant means they are asking Kb in absence of catalyst. That means Kf should be this one, the one which was in absence of catalyst. Just put the values and get the answer. K equilibrium, that is given to us as 2 multiplied by 10 to the power 3, that equals to Kf in absence of catalyst, that is this, 4 multiplied by 10 to the power minus 6 divided by Kb. This will be the rate constant for the backward reaction in absence of catalyst. Let's do the calculation. Kb will be equal to 4 multiplied by 10 to the power minus 6 divided by 2 multiplied by 10 to the power 3. So this gives us 2 multiplied by, this goes up 10 to the power minus 9. So option C will be the correct answer. I hope you understood this. Very simple question. Moving on to next question. Question number 11, which is, which of the following halides will not undergo oxidation with dimethyl sulfur oxide? All right, DMSO. We are doing the DMSO oxidation, dimethyl sulfur oxide. So we need to understand that DMSO attacks on the electrophilic carbon in SN2 manner. So attack of DMSO, the oxygen of the dimethyl sulfur oxide, this is your dimethyl sulfur oxide. Attack takes place through the oxygen, SN2 attack. All right. So if they're asking you that which will not undergo oxidation, meaning just find that molecule which does not support SN2 mechanism or which will not let SN2 to take place. So one thing is quite clear to us that 3 degree doesn't support SN2 because of the steric problem. See, this one is at the benzylic position, number 1, that is favored for the SN2. And then this is 2 degree. This one is a 3 degree carbon. So this obviously will be our answer because of the steric problem. SN2 reaction is not going to take place. Okay, we are checking the degree of that carbon to which halogen was attached, because that in the CX, this carbon is electrophilic. The nucleophilic attack of DMSO is going to take place on this. So you need to consider the steric factor on the carbon to which X is attached. All right. So you clearly see that this carbon to which bromine is attached is 3 degree. Since this is 3 degree, here SN2 will not take place. So that's why our correct answer should be B. Let's see the others as well. You see, this is the benzylic position over here. This will surely favor SN2. And over here, the carbon, first of all, primary. Second thing is that this is on the alpha position to the CO. This is also going to favor SN2 reactions. So I hope you understood this. Simple option B will not be able to get oxidized because of the steric problems. SN2 attack will not be possible over there. So I hope you understood this. Moving on to next question, which is question number 12. The Kf and Kb value of solvent. All right, let's write what's given to us. Kf of solvent, all right, it's 5 Kelvin kg per mole, fine. And the Kb value is mentioned to us, that is 14 Kelvin kg per mole, fine again. Then it says the boiling point of pure solvent is 84. So let's say that Tb is the boiling point of pure solvent. That is mentioned 84 degrees Celsius. And its freezing point is minus 2 degrees Celsius. So let us say Tf denotes the freezing point of the pure solvent. That is minus 2 degrees Celsius. Fine. What is the boiling point of a solution of solute X if it freezes at minus 2.75 degrees Celsius? All right. So they have mentioned as Tf dash. Tf dash is the freezing point of the solution, not the pure solvent. Tf is the freezing point of pure solvent, and Tf dash is the freezing point of solution. Right. Tf dash is given to us as minus 2.75 degrees Celsius. We understand that when you add a non-volatile solute to a solvent, there will be a depression in the freezing point and elevation in the boiling point. That's a colligative property we know. That the final freezing point, if you add the solute to a solvent, freezing point drops. So it drops from initial. By how much it drops? This is the freezing point at of pure solvent minus the drop. This is the drop in the freezing point. So let us find, this is the colligative property, delta Tf, change the depression in the freezing point by how much the freezing point has dropped. Can we write delta Tf equals to the freezing point that we had for the pure solvent, which is minus 2, and this goes that side, minus plus 2.75 degrees Celsius. This is also in degrees Celsius. This is also in degrees Celsius. Will it be 0.75 degrees Celsius? So delta Tf, the depression in the freezing point is 0.75 degrees Celsius, means the freezing point has dropped by 0.75 degrees Celsius. Okay, do we need to consider the unit of delta Tf? Whether you take in the Kelvin, the difference part. If you take the difference of the temperature in degrees Celsius or Kelvin, it is going to be the same. It is going to remain 0.75 only. So we don't really need to get bothered about the unit part over here. Delta Tf, you can take in the degrees Celsius or Kelvin, same result. All right. See, delta Tf, that's a colligative property. And colligative property, this will be equal to I Kf multiplied with the molality of the solvent. All right. So delta Tf is mentioned to us. We got it. It's 0.75. That equals to Kf value is mentioned to us, which is 5 multiplied by I. We don't know. M we don't know because we have no idea about the solute over here. Which solute is it? So this will be 5 multiplied by IM. Let's call it equation number 1. All right. Why we are not worried about IM? It's because we know that we have to deal with the another, which is the elevation in the boiling point over here. That will also include IM, the Van 't Hoff factor and the molality. All right. For the same solution for which delta Tf came out to be this, delta Tb, the elevation in the boiling point, which will be the boiling point of the pure solvent minus, sorry, this is going to be the delta TB, the elevation, because the boiling point increases, that is going to be the boiling point of the pure solution, solution minus boiling point of the pure solvent. But this is a colligative property, and that will be equal to I into Kb. Kb is mentioned to us as 14 multiplied by the molality. Do we know the TB dash? No, that's what we need to find. All right. So TB dash equals to TB dash minus TB, we know. TB is 84 degrees Celsius equals to 14 multiplied by IM. From equation number 1, do we know IM? Yes, we know. Just manipulate this equation a little bit. You are going to see IM equals to 0.75 divided by 5 equals to 0.15. All right, let's put the values over here. So TB dash means the boiling point of the same solution will become 14 multiplied by IM. The value of IM that we got is 0.15. So 0.15 multiplied, not multiplied, this goes that side, so plus 84. So what do we get? Let's solve this. So this will be 60, 21, and then 2.1 plus 84. So this is going to be 86.1 degrees Celsius. That will be the correct answer for this question. I hope you understood this. 86.1. This. Option C will be the correct answer for this question. I hope you understood this. Moving on to question number 13 now. Question number 13, it says the correct order of increasing XOX bond angle. All right. So we have on all the options, same things given. So let's pick water, H2O. Then we have OF2. And then we have Cl2O, OClCl. All right. Let's see this. Between these two, it's easy to tell. Let's tell that. You understand that here, hybridization, if you talk about the hybridization of the oxygen, everywhere oxygen is sp3 hybridized. In all the three cases, oxygen is sp3 hybridized. So angle should be somewhere around tetrahedral angle only, which is 109 degree, 28 minutes. Now, they all have same number of lone pairs as well. Two lone pairs. Each one got 2 and 2 lone pairs. Fine. Means the steric number is same. In the steric number, of course, it has to be same, then only hybridization will be same. Here, bond pairs are same in all the cases. There are 2 bond pairs and there are 2 lone pairs. Right. Now, how do we decide the bond angle? Now, we consider the electronegativity of central atom and the side atom, C. If you consider these two, oxygen is more electronegative than hydrogen. So it will pull the electrons closer to itself. Fluorine is more electronegative than oxygen. So electrons shared will be away from the oxygen. What's the problem with electron shifting? There is that's what we are going to see. If electrons are closer to the central atom, the distance, this distance become lesser. And if it is away from the central atom, distance between the bond pair, this distance become more. Because the distance become more, so repulsion between the bond pair electron become less. Since the distance become less, so the repulsion between the bond pair electrons increases. Now you tell yourself that this bond, which bond should come closer? Which bond? Here you have the lesser repulsion. Since you have lesser repulsion, so they will be repelled more by the lone pairs. Bond angle will reduce in this. Since here you have more repulsion with respect to this, electrons are closer, so repulsion between the bonds are more, so bonds will be, the bond angle is going to be more than this case. So one thing that we got, that OF2, because of the higher electronegativity of fluorine, bond pair electron shifts away from the central atom, distance between the bond pair electrons increases, so repulsion between them decreases, so the bond angle decreases. So OF2 will have lesser bond angle than H2O. We are clear about this. Cl2O, this is quite an interesting case over here. There are two factors at the play over here. One, large size of the group. Because of the large size of the group, there is the groups over here have large size. Because of that, you will see the repulsion between the groups. And if you see the repulsion between the groups, they would like to get away from each other as far as possible, meaning they will have the tendency to increase the bond angle. That is number one, first thing. Second thing is that chlorine got vacant d orbital. This chlorine also got vacant d orbital. Oxygen got lone pairs, fulfilled orbitals. Fulfilled orbitals with the vacant d orbital. You will be seeing a case of back bonding over here. Same over here, back bonding. That's a condition for the back bonding, that if you have a fulfilled orbital and a vacant orbital present on the adjacent atoms, you will be seeing the back bonding taking place. Because of the back bonding, there will be extra electron density, more electron density between the OCl bonds. Means the electron density has increased due to this back bonding. Since the electron density over here, the electron density is more. Over here, the electron density is more. So bonds are going to repel more than. If the repulsion between, if the electron density is increasing over in this area, then the repulsion between the bonds are surely going to increase. That is also tending to increase the bond angle. So there are two factors. This also is trying to increase the bond angle. The electron density, increased electron density due to the back bonding is also trying to increase the bond angle. Combined, the two factors combined, the bond angle in Cl2O become greater than both of these two. In fact, it become greater than the tetrahedral angle as well. 109 degree 28 minutes. So this is one of the case where the bond angle become greater than the expected ideal angle. In fact, angle over here is 101 degree. Sorry, 111 degree. So let's see which one has the correct option. Both of these two have the angles lesser than 109. This one has angle around 104. This one has the angle even lower than 104 degree. So let us see which one is the correct option. Cl2O should have the maximum. So this one is the answer. Anywhere else? No, this one is the correct answer, B. Let's check the sequence, by the way. Cl2O most, that's correct. F2O least, that's correct. That's why B will be the correct answer. I hope you understood this. Moving on to question number 14 now, which says, the treatment of D-fructose with the concentrated HCl mainly gives product P. The degree of unsaturation of the product P will be what? See, this is, you are treating the D-fructose with the concentrated HCl. So this is going to give you HMF. Now what is HMF? So when you take the D-fructose and when you treat it with the dehydrating reagent like the HCl concentrated or concentrated H2SO4, so this is going to produce HMF. This is also called as 5-HMF. CH2OH. This takes place due to, okay, here also, polydehydration of D-fructose. This produces HMF. What does the HMF stands for? This hydroxymethyl furofil. All right. This will be the final product. If you treat the D-fructose with a concentrated HCl, polydehydration takes place. This thing forms HMF. All right. So here, this is the product P. They're asking you the degree of unsaturation. So for degree of unsaturation, just see how many double bonds you have and how many cyclic structures you have. So here, because of the ring, degree of unsaturation 1. Fine. 1 multiple bond. So degree of unsaturation 1 here. 1 more multiple bond, degree of unsaturation 1 here, and 1 more multiple bond over here, so degree of unsaturation 1 here. That's all. 1, 2, 3, 4. So the correct answer will be option C. I hope you understood this. Moving on to question number 15, which is this. All right. Directly on the, they have given you the substrate, quite a popular reactions they have given. So they have mentioned the substrate, they have mentioned the reagents, and you have to tell what what is the name of the reaction. So if you remember this is aldehyde. You are taking it with the in the alkali medium, and then you are treating with the H plus. This carbon, the carbonyl carbon, doesn't have an alpha hydrogen. And then in the presence of the basic medium, you know that this is called Canizaro's reaction. So this thing, very clearly, Canizaro's reaction, where is it? We'll see, that must be in the fourth one. This one, phenol with CO2 NaOH, then heating, the H plus. This one is Kobe-Schmidt reaction. This introduces the COH group. You know, this thing in here, in the Canizaro's reaction, this is a kind of disproportionation reaction. Here, this reaction is shown by the aldehydes which do not have the alpha hydrogen. That oxidizes into the carboxylate ion and reduces into the corresponding alcohol molecule. That's the Canizaro's reaction. I hope you remember. In this, COH group is introduced at the ortho position. That's the Kolbe-Schmidt reaction. This thing, a very popular reaction, you can see KOH. This is the thalamide reaction with the potassium hydroxide CH3Cl. This reaction produces the primary amine Gabriel thalamide synthesis. Directly looking at the reagents, you can tell. So as soon as you see the thalamide with the KOH, that's the Gabriel thalamide synthesis that gives you the primary amine. The reaction with the RX over here, this R forms the amine. All right. So this is the method of preparation of 1 degree amine, a very good method. And then in the end, you have phenol with the chloroform, and this is the Riemer-Tiemann reaction. This introduces the CHO group, CHO, the aldehyde group on the ortho position. So the correct answer will be 4 Canizaro's. Canizaro's is for A, P. So P is with 4. So where P is with 4, P is with 4. Let's cancel this out. P is with 4. Fine. Then we have Q with 3. So Q with 3, Q with 3, Q with 3. Fine. Let's cancel this out. Okay. Then we have R with 1. R with 1. This cancelled out. Option D will be the correct answer. Of course, S will be the second one then. I hope you understood this. Very popular reactions. You should, in fact, remember all the name reactions. Moving on to question number 16 now. Which of the following set of elements have the most negative electron gain enthalpy? All right, most negative electron gain enthalpy in their respective groups. Fine. So we have to identify the groups. We should know that the element belongs to which group and whether they have the most negative electron gain enthalpy or not. So in the sulfur belongs to the oxygen family. Yes, sulfur has the maximum. We know that maximum electron affinity, or say the most negative electron gain enthalpy, most negative electron gain enthalpy in group 16. So that is true. Sodium, no, that's where it went wrong. In the first period, in the first group, it's a lithium, which got the most negative. So that's where it goes wrong. Even the fluorine is wrong. In the 17th group, chlorine has the most negative. So option A, eliminated. Option B, sulfur from 16, yes, that has the most negative. Chlorine from group 17, yes, that has. Neon, all the noble gases have positive electron gain enthalpy. They're asking you the most negative. So this will not be the answer. That's incorrect. Because of this, we'll be eliminating this. C, sulfur, yes, group 16, the most negative. In group 15, you must know this, that in the group 15, when you go down, the electron gain enthalpy become more and more negative. So the last member, antimony, that has the maximum. Electron gain enthalpy in the group. This antimony will have the maximum. Chlorine in the group 17 has maximum, meaning most negative. So clearly option C is the correct answer. I hope you understood this. Moving on to question number 17 now. Acidity of the labeled hydrogen is, all right. So we have to tell about this, and this. All right. If you see, we are removing the hydrogen from the oxygen. Oxygen will get the negative charge, and that negative charge will be stabilized by the resonance over here. Question is that how to decide which hydrogen is going to be acidic? So you have to see the simple thing. Any acid, if it loses the hydrogen, it becomes A minus. More stable A minus, acidic strength of HA will be directly proportional to the stability of conjugate base that is forming the anion. More stable the anion, stronger the acid will be. So from wherever, whichever hydrogen they have indicated, from there, if you're removing the hydrogen, the minus charge will come right at that point. You just need to compare the stability of C minus formed at those positions. So indirectly, this is, here you have to check the stability of the conjugate base. So you see, in this case, if you remove the hydrogen, the negative charge will come on the oxygen, the most electronegative among these. From here, you'll be removing the carbon, from the carbon, from carbon, from carbon, from carbon. Here, you're removing from the oxygen. So that is first thing, that since you'll be removing from the more electronegative element than any other cases. And the second thing is that the minus charge which will come on this will be resonance stabilized by the benzene ring. So E obviously has to be the most acidic. E has to be most acidic. So eliminate option A and eliminate option B. After this, the active methylene group must, your attention, your focus must come back on the active methylene group. You understand that. If C minus forms over here, how will it form? By removal of this H plus. If you remove this H plus, the minus charge formed over here will be resonance stabilized. And the resonance stabilization over here is more than the C position, because here the resonance is in this direction only, and here there is more resonance. That's why active methylene group will be more acidic than any of others. Here C minus on the sp2 carbon, not in the resonance. Here C minus on the benzene, and you understand that benzene doesn't support any reaction. That's aromatic. It doesn't support the removal of the hydrogen. It's aromatic. It's already highly stable. So removal of H plus is going to be difficult. That is one thing. Second thing is that C minus that is formed is not going to be resonance stabilized as well. All right. So comparing B, one thing were sorted with, that E is going to be most acidic. Comparing A, B, C, and D, that obviously is going to be the least one. So D least, both options say this, eliminating option A and B. Comparing A, B, and C. If you look at this, if C minus formed over here, that will not be in the resonance. So that is not resonance stabilized. If it forms over here, that will be resonance stabilized in the two direction. If it forms over here, it will be resonance stabilized in just one direction. So the best stabilization among A, B, and C is at the point B. That's why B should be the second after E. So then B should be the second. Comparing C, A, C has the resonance over here, C minus. So that's why C, but over here, it's not in the resonance. That's why C will be, C, the hydrogen on this hydrogen will be more acidic than A. So C will be greater than A, and the least, of course, will be D. You understand that the aromatic compounds are almost not non-acidic. They do not give H plus that easily. The reason being highly unreactive. I hope you understood this. Moving on to question number 18 now. All right. So we have to match the following. Okay, based on the force of attractions that we'll be seeing over there. Clathrate compounds of xenon in the ice. The clathrate compounds, what are these compounds? So clathrate compounds are basically ice. Example, for example, ice. The lattice of ice, when the ice forms under high pressure, within the crystal, some xenon gets trapped. This itself, this trapping of the gas within the lattice is what you call the clathrate compounds. Over here, the xenon trapped is not chemically bonded to ice. It's not chemically bonded. It's just trapped. And the attraction, that force of attraction that is operating over there is purely physical force of attractions. All right. So xenon is a neutral atom, right? And then you have the polar water molecule surrounding this. This xenon is trapped in the case-like structure. The ice, there you have the water molecules all around. They are forming the crystal, the lattice, and xenon is stuck in the gaps of the lattice. All right. So what kind of attractions is over here? You understand that water is a dipole. Oxygen being negatively charged, hydrogen has the positively charged. This dipole induces the dipole in the xenon molecule. So this part, if it is, that depends on which atom it is interacting with. If it is interacting with the hydrogen, this part will have more negative charge and this part will have more positive charge. So basically, water, which is a dipole, it induces the dipole in the xenon atom. So in the compound of clathrate compounds of xenon in the ice, it will be dipole-induced dipole kind of interaction, meaning P will be 3, not D, not A. Let me tell you this, that clathrate compounds, these are like quite an interesting topics to study, and these are like the topic of research as well these days, because deep down in the sea, there are many natural gases which are trapped in the form of clathrate compounds, and they can be a potential source of energy in the near future. Many countries have dedicated a program for that part only. Moving on to the next part, liquefaction of the xenon gas. All right, xenon gas completely non-polar. In the non-polar, you will have the London forces. So xenon with another xenon, temporary dipoles are created, London forces are there. So in the liquefaction of xenon gas, there will be the London forces responsible. Momentarily, the dipoles are created in the atoms of the among the atoms of the xenon. So that's nothing but the London forces. Liquefaction of the HCl gas. HCl is a dipole, you understand that. HCl is a dipole, negative on the chlorine and positive on the hydrogen. It attracts the another HCl molecule by dipole-dipole interaction. Dipole and dipole are interacting. So because of that, their liquefaction of HCl gas will be possible. So that will be 2. And then hydration of Na+. Na+ is a full-fledged ion. Hydration means its association with the water. Na+ associates with the water via ion dipole interaction. This is the dipole, this is the ion dipole interaction. So S will be 1. So correct answer will be P should be 3. P should be 3, all right. Then Q should be 4. Then R should be 2. This is the correct answer. I hope you understood this. All right. Moving on to next question. Question number 19. The iodide content of a solution was determined by titration with CeSO4 in the presence of HCl, in which I- is converted to ICl. Fine, I- is converted to ICl. A 250 milliliter sample of the solution required 20 ml of 0.05 normal C4 solution. What is the iodide concentration in the original solution in gram per liter? Okay, focus on this. We need to find it in the gram per liter. All right. Question is that the volume of this iodide solution was 250 milliliter. All right. This solution needs this much C+4. All right. So C+4 needed, the volume for this needed was 20 milliliter, and the normality of this was 0.05. All right. Okay. So we need to find the iodide concentration in the original solution. Okay. So if this much of C+4 can completely convert the I-, whatever I- you had in the solution, into ICl, that obviously means the equivalent of this must be equal to the equivalent of iodide ion in the solution. Number of equivalents must be same. Because this much of C+4, which comes from CeSO4 of course, this much equivalent of Ce+4 is able to convert I- completely into ICl. And according to law of equivalence, the equivalence of C plus 4 in this solution must be equal to equivalence of I minus in the 250 ml solution. Law of equivalence, right? So here, either you can say number of equivalents are same, or you can say milli equivalents are same. So because volume are given to us in the ml, so let us solve this. Can I say here volume is known to us? So the number of milli equivalents, let's solve in terms of the milli equivalents of I minus. Should that be the milli equivalents? You understand that normality equals to number of equivalents by volume. If you take the volume in milliliter, in that case, the number of equivalents over here can be written as normality into volume. If you take the volume in milliliter, the number of equivalents will be milli equivalents. All right. So milli equivalents will be the normality of the I minus, fine, multiplied by the volume of the solution. Let's keep it in the milliliter itself. And normality of iodide ion multiplied by the 250 volume. All right. Here, the milli equivalence of Ce plus 4, that is normality of the Ce plus 4 multiplied by the volume in ml. Okay. If these two have reacted completely, these two equivalents must be equal. Let's find the normality of I minus. Normality of I minus multiplied by 250 must be equal to the milli equivalence of C plus 4, 0.05 multiplied by 20. What do we get? Normality of the I minus comes out to be, this is 100 divided by 100 multiplied by 1 by 250. Okay, this thing is basically 1. All right. So normality of the iodide ion comes out to be 1 by 250. Fine. This is the normality. If you want to find the gram per liter, you need to find the how many moles you have in per liter, meaning if you find the molarity, finding the gram per liter concentration will become very easy for us. But if you want to convert normality into molarity, because one thing we know, normality equals to molarity multiplied by n factor. So molarity is going to be normality by n factor. So what is the n factor for this solution? Let's solve this. This is in -1 over here. This one is in +1 over here. If you see, the change in oxidation number per mole of I minus comes out to be 2. And whatever the change in oxidation number per mole of this species, that is what you call the n factor. So n factor over here is 2. So molarity of iodide ion will be the normality 1 by 250 divided by n factor, meaning this divided by 2, 1 by 500. That will be the molarity of iodide ion. All right. So the molarity we got 1 by 500. Fine. Molarity is 1 by 500. Atomic mass is already given to us. So molarity means what? Molarity means 1 by 500 moles in 1 liter of solution. Correct? That's what the molarity means. How many moles of solute you got per moles of the solution. All right. So 1 by 500 moles, meaning 1 by 500 multiplied by the molar mass is given to us as 127. This much grams of iodide ion in 1 liter of solution. Just solve this. We'll get the answer 127 by 5 into 10 to the power minus 2 gram per liter, which is nothing but 25.4 gram per liter. That will be our answer. Let us see. Okay, we have done some mistakes somewhere. Let us quickly recheck the calculation. Normality into 250 equals to 0.05 by 20. All right. So here 100 by 100. Let us do this calculation once again here. 100. All right. To 1. Okay. 1 by 250. That's what we should get. Yes, that's correct. So molarity equals to 1 by 250 divided by the n factor. N factor is -1 plus 1. Yes. by 2, so 1 by 500. So molarity comes out to be 1 by 500. This. Molarity. Let us see. 1 by 500. We have to find in moles per grams per liter. All right. All right. We forgot to take this. This is 25.4 multiplied by 10 to the power minus 2. We forgot to take this thing into the consideration. That should be 0.25 grams, 254 grams per liter. I hope you understood this. That was the mistake over here. We forgot to consider this. So the correct answer will be option C. I hope you understood this. Moving on to question number 20. Question number 20, it says, phenol with bromine water. You understand that polybromination takes place. So directly option B will be the correct answer. I hope you understood this. If you had taken it in the presence of CH2, only monobromination takes place. We are aware of that. Moving to question number 21. Which is the wavelength of the second line of the Balmer series. Balmer series of a hydrogen-like species. All right. So Balmer series, second line. Balmer series means the transition is taking place to, let us say, N1 is the destination shell where the electrons has to come. So electrons are coming to the second shell. From where? It can come from any higher shell. Second line would mean the next to next shell. The electrons are coming from the not third shell, fourth shell. Next to next shell. All right. First line would mean third to 2. Second line would mean 4 to 2. All right. So N2 is 2 and N1 is 2 and N2 is 4. So from applying the Redox equation, we can write 1 by lambda. Let us call it lambda 1 for the Balmer series in the hydrogen-like species. We can write it as RZ square because we don't know which species is it. So atomic number is not known to us. Multiplied by 1 by N1 square. N1 is 1 by 4 minus 1 by N2 square, 1 by 16. Putting these values, we see 16, 4 minus 3, 3 by 16. That will be 1 by lambda 1. Let's call it equation 1. And then wavelength of series limit. Series limit means the electrons are coming from n equals to infinity. All right. Of hydrogen atom in the Lyman series. Lyman series would mean that N1 equals to 1 electron has to come to the first shell, but series limit would mean N2 has to be equals to infinity. So let's call the wavelength associated with that as lambda 2. Lambda 2 is the series limit, wavelength of the series limit. Can we write it as R, Z of the hydrogen is 1. So into 1, that thing will be 1 by N1 square, 1 by 1 minus 1 by infinity square, which is nothing but the 0. This comes out to be R only, equation number 2. Okay. One relation they have already mentioned to us in the problem, which says that lambda 1 is 4 by 3 times the lambda 2, which is the series limit in this. So 4 by 3 times lambda 2. All right. Let's keep that in the mind and let's take the ratio of the first two equation. What do we get? R and R cancels out, nothing else down there. What are we left with? Do we get lambda 2 by lambda 1 equals to Z square into 3 by 16. Right? This is what we got by dividing these two equations. From here, can we write lambda 2 by lambda 1 equals to lambda 2 by lambda 1 equals to 3 by 4. Lambda 2 by lambda 1, we can put 3 by 4. That equals to Z square into 3 by 16. Let's just solve this. What do we get? Z square comes out to be 4. So Z will be equal to 2. So atomic number of that hydrogen-like species must be 2. I hope you understood this. In question number 22, we have Hoffmann bromamide degradation reaction given to us. The question asked is the number of moles of bromine and the NaOH that will be consumed with 1 mole of CH3CH2CONH2 to prepare this 1 degree amine CH3CH2NH2. Let us say the number of moles of bromine required are X and number of moles of NaOH required is Y. Then the question is what should be X plus Y? Right. This is a very good question based on the mechanism. If you know the Hoffmann bromamide degradation reaction, then you can easily answer this. Or else, if you know the whole equation, then also you can answer this. So the whole equation for this reaction, if I have to write the overall reaction, we got CH3CH2 CONH2. Right. This is the amide that we have. Amide when taken with Br2 and NaOH. This gives us a reaction where primary amine is produced. The primary amine produced, how do you make it? Simply just remove this part, attach the NH2 group directly to this carbon. You will get primary amine. So the primary amine formed over here will be CH3CH2 and this directly attaches to this NH2. Primary amine formed. All right. Then NaBr is also formed. CO2 is released, which in the water, which finally become Na2CO3. And then some water molecules are also produced. Either you know this whole equation or you know the mechanism of the reaction, then and only then you will be able to answer this question. All right. So if we have this equation, if we know each and everything that is participating in the reaction or the products that are being produced, if somehow we know that, we can simply balance the equation and tell the answer. All right. So if we balance this equation, what do we see? You would need 2 moles of NaBr over here and then Na2CO3. This will be 4 moles of NaOH and then you will be needing 2 moles of water over here. This is the balanced equation that you will be having in the Hoffmann bromamide degradation reaction. Question asked is how many moles of, for 1 mole of this, you can clearly see in this balanced reaction, for 1 mole of this, you require 1 mole of Br2 and 4 moles of NaOH. Per mole of the amide will require 1 mole of the Br2, 1 unit of the Br2, and 4 units of the NaOH. Meaning, this is the value of X. X equals to 1. Y equals to 4. X plus Y, you can simply answer it now. 1 plus 4 will be equal to 5. So the answer for this question should be 5. I hope you understood this. Either you know this full equation or you'll have to write the mechanism. You will see that 4 moles of OH minus is involved in the mechanism. So the answer for this question will be 5. I hope you understood this. Moving on to the next question. Question number 23. So what do we have in question number 23 is this. The oxidation states of iron atoms in compound A. Okay, this is A. So A is Na4FeCN whole 5 NOS. Then this is A. The compound B is this Na4 FeO4. That's compound B, and we have this compound as compound C. This is Fe2CO whole 9. So that's the compound that we have. So A, B, and C is mentioned to us. They're asking us to find the oxidation number of iron in each one of them, and they're saying that the oxidation number of iron in A is X, in B is Y, and in C it's Z. You have to give the answer for X plus Y plus Z. So if you want to answer what will be X plus Y plus Z, you need to know what is the oxidation number of iron in these compounds. So let's find the oxidation number of each elements involved over here. Sodium, the first group element. First group element in any compound will be in the +1 state. Iron, we have to find. Cn, we know that's -1. Each Cn carries a charge of -1. NOS, that also carries, each NOS will carry -1. We know the concept that sum of oxidation number of each species involved over there should be equal to the net charge over the molecule. So net charge over the molecule, it's a neutral molecule, no charge on this. Let's take the sum of each component over here. So you got 4 sodium. Each sodium shows +1. Then iron, you got 1. So we have assumed the oxidation number is X. They have asked you to assume this. And then you got 5 Cn. Each Cn in -1. So there are 5. Because of 5, it will be 5 into -1. Then we have NOS. 1 NOS only, 1 carries -1. And the net charge over the molecule, that is 0. Let's calculate X. This will be 4 plus X minus 5 minus 1 minus 6 equals to 0. X will be equal to minus, this side -2 goes that side. X will be equal to +2. So oxidation number of iron over here is +2. So we got the value of X. That will be +2. In second compound, once again, sodium in any compound, the first group element, if you see in any compound, that is going to show +1 oxidation state only. So +1 here. Oxygen, we know, -2. Iron, we assumed Y. Let's take the sum of oxidation number of each atoms involved over here. And that sum should be equal to the net charge over the molecule. Net charge over the molecule is 0 once again. So 4 sodium, each sodium +1. So 4 multiplied by +1. Iron, we have assumed Y. 4 oxygen, each oxygen in the -2 state equals to the net charge, which is 0. Calculating Y from here, 4, 4, here -8. So Y will be equal to -8 plus 4. -4, this side goes that side, become +4. So the value of oxidation number of iron in the second compound, which is B, will be +4. Let us solve for C also. Carbonyl group, it's a neutral group, 0 charge. Net charge over this molecule is 0. So sum, once again, the same concept. The sum of oxidation number of each atom involved must be equal to the net charge. Let's take the sum. 2Z plus 9 into 0, 0 itself equals to 0. The value of Z comes out to be 0. So oxidation state of iron in the third compound is 0. So we know the value of X, we know the value of Y, we know the value of Z as well. You have to find X plus Y plus Z. That's what they are asking. You have to get X plus Y plus Z. So X value 2, Y value is 4, Z value is 0. Net sum will be 6. And that is what is going to be your answer. I hope you understood this. Simple question based on finding the oxidation number. Moving on to question number 24, which is the compound among following which can give 2,4 DNP test. The full form of 2,4 DNP is dinitrophenyl hydrazine test. So who gives this test? This is the characteristic test of carbonyl compounds. This will be the test of carbonyl compounds. Whichever compound has the carbonyl group present, ketone or aldehyde. Ketone and aldehyde, these two are going to show the 2,4 DNP test. So let's identify which compounds have the ketonic or aldehyde group. So this compound clearly, this doesn't have the carbonyl group. This one is aldehyde group over here. So this one is your, this will show the 2,4 DNP test. Question, the third one, that is ketonic group present over here. So this will also show. Fourth, it won't show, that doesn't have ketonic or aldehyde group. Fifth one, same reason, no aldehydic or ketonic, so won't show. This one is the ketone over here, C double bond O. So this will show. Seventh one, this will not show. This is the carboxylic acid. Carboxylic acid will not give you the 2,4 DNP test. Aldehyde, HCHO, this will show. This ninth one, alcohol, phenol, this will not show. 10th, alcohol we got here. So this will show. Question is, how many gives the total number, the compound among which can give 2 for DNP test. So we have 1, 2, then 3, and then 4, and then 5. So we have 5 compounds over here, which will give 2, 4 DNP test. And directly you just need to identify the compounds which contains the ketonic or aldehydic group. All right. I hope you understood this. Moving on to question number 25. So question number 25 says you have 1 mole of calcium carbonate, all right? So we have CaCO3 heated. When you heat the calcium carbonate, you get the calcium oxide solid plus CO2 gas, all right? Calcium carbonate is also solid, we know that. Fitted with a frictionless movable piston at 1 atm, okay? Temperature 300 Kelvin. Calculate the work obtained. Okay, let's focus here. You have to give the work in calories. They have given you the value of R also to use when you want to find the work done in the calories. Fill your answer as sum of digits. All right. So what we have over here, for work done, we know that the work done is equal to minus P external into delta V, or simply minus P external, we can write it as PV. This thing, whole thing can be written as this. Delta of minus delta of PV. And for ideal gas, PV equals to nRT. So from this, we can derive this formula, delta NGRT. PV equals to nRT. So if there is a change in the PV, that must be changed.
Hello students, so we'll continue with this JEE main paper discussion. So the question number 1 says, if x square plus y square equals to k square, where x and y are variables and k is constant, then x and y can be taken as a x equals to k cos theta and y equals to k sin theta. Further, they are saying if x square plus y square equals to 9, then minimum value of this expression we have to tell. Okay. So first of all, what they have given, x square plus y square equals to 9, right? This is what they have given. Now, so here, as per the given information, if x square plus y square equal to k square, I can assume x equals to k cos theta and y equal to k sin theta. So here, I can take x equals to 3 cos theta and y equals to 3 sin theta, right? Now we need to find the minimum value of this expression, right? So let's say for the time being, this expression is equal to E. So E equals to 9 by x square plus 9 by y square. Just put the values here. X square. So x value is 3 cos theta. So we'll put 3 cos theta whole square plus 9 divided by 3 sin theta whole square. Okay. Further simplifying, 3 square will be 9. 9 and 9 will get cancelled. So I'll be simply getting 1 by cos square theta plus 1 by sin square theta. 1 by cos square theta is nothing but secant square theta, or you can say sec square theta, plus 1 by sin square theta, which is nothing but cosecant square theta. Now, further secant square theta can be written as a 1 plus tan square theta plus cosecant square theta can be written as a 1 plus cot square theta. So my E comes out to be 2 plus tan square theta plus cot square theta. Okay. Now tan square theta plus cot square theta. Here what I can do, I can apply AM greater than or equal to GM inequality, right? So arithmetic mean of these two numbers, which is A plus B by 2, will be greater than equal to square root of tan square theta into cot square theta. And 10 into cot will be 1. So from here, I'll be getting tan square theta plus cot square theta will be greater than or equal to 2, which means that we have got this quantity will be greater than or equal to 2. So from here I'll get that E will be greater than or equal to 2 plus 2. That means my E will be greater than or equal to 4. So from here I can say that minimum possible value of E will be 4. Okay. So now we can check with the option. So we are getting option D is our correct answer. Option D is our correct answer. Clear? Let's move to the next question. And before that, we can check the option. D is the correct answer given. Now, question number 2 says, if the two roots of this equation are real and distinct, then the set of all values of A we need to find. Okay. So now, first of all, we need to see this expression, which is x power 4 plus x square plus 1. Okay. This one we can factorize into two quadratic factor, which will be x square plus x plus 1 times x square minus x plus 1, right? So if I just put these values over there, so I'll be getting a minus 1 times x square plus x plus 1 times x square minus x plus 1 plus of a plus 1 x square plus x plus 1 whole square equals to 0. So from here I can see x square plus x plus 1 will be a common factor. So if you take that common, so I'll be getting x square plus x plus 1 common. If you take, you will be left with a minus 1 times x square minus x plus 1 plus a plus 1 x square plus x plus 1. Now here we can see that x square plus x plus 1, this will have imaginary root, right? Because if you check the discriminant of this number, discriminant of this quadratic equation, that will be negative, right? If you see d equals to b square minus 4ac is negative, that means this quadratic equation will produce imaginary roots. Okay, imaginary roots, or we can say roots will be imaginary number, same thing. So from here we are not going to get any real and distinct root, but they are saying this will have real and distinct root, which means that whatever the real and distinct root will come, that will come from the second part, right? So if we further simplify, so I'll get a minus 1 x square minus of a minus x plus a plus 1 a minus 1 plus of a plus 1 times x square plus a plus 1 times x plus a plus 1 equals to 0. Now take the x square common from this one and this one. So I'll get a minus 1 plus a plus 1 minus of, let's collect the coefficient of x. So if you take x common, I'll be getting minus a plus 1 plus a plus 1. And what about the constant part? Here minus 1 and plus 1 will get cancelled. A plus a will become 2a. So 2a equals to 0. So I'll be getting x square times 2a plus a will get cancelled. So I'll be getting 2x plus 2a equals to 0. So we can take 2 common and we can remove 2 from here. So I'll be getting ax square plus x plus a equals to 0. Now this quadratic equation need to have real and distinct root. When it will have real and distinct root? That is only possible if my d is greater than 0. So if you apply d greater than 0, what will happen? b square minus 4ac will be greater than 0. So from here, you can factorize it. So you'll be getting 2a minus 1, 2a plus 1 will be less than 0. So you can see, now we can apply the wavy curve method. Here we'll have minus half, here half. So plus minus plus. Now, from here, what are the values of a will get? We need less than 0. So a belongs to minus half to 1 by 2. But there is one small things we need to understand. If you put a equal to 0, this won't be even a quadratic equation, right? Because then it simply become x equal to 0. So basically a equal to 0 cannot be the value. So what we need to do is, my a will become, a belongs to minus half to half, but we need to remove 0. We need to remove 0. And same information here, if I want to write, that can be written as a minus half to 0 you go, take union 0 to 1 by 2. Got it? So now we can check with the option. Option B will be correct answer, right? So this is how we can solve this question. So here, this is the important factorization which you are supposed to keep in mind. Okay. So let's check the answer here. So option B, minus 1 by 2 to 0, union 0 to 1 by 2. Okay. So moving ahead with the next question. Here they are saying find the range of the function f of x equal to this. Okay. So first of all, if I focus on the domain of this function, okay, so we know that here square root expression is there, and we know that my square root expression will be defined only if the quantity inside the square root should be non-negative, right? So we can say that here my 1 minus x square should be greater than equal to 0. That implies x square minus 1 should be less than equal to 0. So we can factorize it. X minus 1, x plus 1 should be less than equal to 0. So from here we can find the values of x, which will be minus 1 to 1. So this is the domain of this function, right? Now here what I can do is, since my x can take any value from minus 1 to 1, so I can assume x is equal to sine theta, or you can say cos theta, because so sine theta also, if I talk about sine theta also, values will be from minus 1 to 1, cos theta also values will be from minus 1 to 1. So if you put x equal to sine theta, so you'll get 1 minus sine square theta root divided by 1 plus mod sine theta. Now we can say 1 minus sine square theta is cos square theta, and root of cos square theta will be mod of cos theta. So mod of cos theta divided by 1 plus mod sine theta, right? So for this function, we need to find the range. So first thing we can observe here, my theta can be any value, right? Theta can be any value from 0 to 2pi. First thing we can observe here, the denominator will be always greater than the numerator, right? That's the first thing. Second thing we observe, numerator is positive, denominator is also positive because of the mode. So this much we can easily ensure that mod cos theta upon 1 plus mod sine theta will always be between 0 to 1. Now corner values alone we need to check whether 0 will be the part of the range or not. Okay. So if you put theta equal to pi by 2, so you can easily check. If you put theta equal to pi by 2, cos pi by 2 is 0, which means this expression can produce the value 0 also, right? Simple logic. If I put theta equal to 0 degree, so cos 0 degree will be 1, 1 upon 1 plus sine 0 degree 0, which means this expression can produce the value 1 also. So from here I can easily see that my range of the function will be 0 to 1, 0 close to 1 close. And that we can see over here, option A will be correct answer, right? So let's quickly check option A, 0 to 1. Like this, we can easily do this question. Now, moving ahead to the next question. Here they are saying f of x is this function, g of x is another function, and h of x is mod of x. Then we need to find this limit. Okay. So basically, this is a composition of functions. So let's focus on h of x limit first of all, right? So if I think about h of x, which is equal to mod x. So if I want to find the h of 0 positive, which is RHL, so directly we can observe this will be 0. And at the same time, if I want to find the 0 negative, so that limit also comes out to be 0, right? Now, for this function, they're asking me to find the limit. So I need to split it separately. I should find LHL and RHL and should check whether LHL and RHL are coming same or not. So first of all, let's look at the LHL of this function, left hand limit. So limit x tends to 0 negative, f of g of h of x. Now you can easily see if x is tending to 0 negative, it will produce the answer 0, right? So what is the value of this? This will be approaching towards 0. Got it? But this will be approaching towards 0 from the which side? Positive side, because of, if you look at this, if x is 0 negative, which means slightly less than 0, then if you take the mode, then this will be slightly greater than 0. So this overall quantity will be slightly greater than 0. So this thing I can relate like f of g of 0 positive. And g of 0 positive means RHL of g function. 0 positive simply means my value of x is slightly greater than 0. That is given over here, right? So from here, if you see what is the f of g of 0 positive. So what will happen here? If you put 0 positive, so I'll be getting 1 minus 0 will be 1, right? So this will be nothing but 1 negative, because x square will be 0 point something. So 1 minus 0 point something will be 0 point something, which means g of 0 positive will be approaching towards 1 from the left hand side. F of 1 negative. 1 negative will be coming from this quantity, 2x square minus 2. So if you put here, so I'll be getting 2 times 1 square minus 2. So I'll be getting 0, which means LHL I am finding, I am getting 0. Similar way, if you want to find RHL, right hand limit. Limit x tends to 0 positive, f of g of h of x. So from here, we'll be getting, if x is approaching to 0 positive, I'll be getting 0 positive. H of 0 positive is also same thing, so it will be 0 positive. And from here, exactly same calculation will follow. So since we know LHL and RHL both are coming 0, hence the value of this limit is going to be 0, which is given in option B, right? So you can see option B is the correct answer, right? Option B is the correct answer. This is how it will work, right? Let's move to the next question. What is the next question? Yeah, here. So here they are saying basically one function is given, okay, and function f of x is given this, that signum of box x when x is not integer, and box of signum of x when x is equal to integer, where signum denotes the signum function and box denotes the greatest integer function. Then we need to comment on all these things, whether my function is continuous, non-differentiable, all these things we need to comment. Okay, so first of all, if I just try to draw the graph of this function, if I just try to draw the graph, because from the graph it will be very easy to observe. So let's say this is my 1, this is 0, this will be minus 1, right? So if I say that my value of x equal to 1, if I put x equal to 1, what will happen? I'll be getting signum 1, and box of signum 1 will be 1, right? And if I put any value which is greater than 1, for example, if I put any value greater than 1, for example 1.2, so box of 1.2 will be 1, and which will again become the signum, then again 1, which means if you take any value of x which is greater than 1, my output will always remain 1. So it will go like this, right? It will go like this, and this value is 1. Got it? Similar way, if I put x equals to 0, so if you put x equal to 0, signum of 0 is 0, box of 0 is 0. So I'll be getting this one, right? If you put any value of x which is negative, so what will happen? Let's say if I put x equal to minus 2, so if signum of minus 2 is minus 1, and minus 2 box will be minus 1, which means that for the moment I put negative value, my graph will go like this. Okay. Now let me take any value between 0 to 1. For example, 0.2. So box of 0.2 will be 0, and signum of 0 is 0, which means that my graph will go like this, right? So this is the graph of which function? F of x. Now we can easily see that my function at x equal to 0, at x equal to 0 it is not differentiable because limits itself is changing, and at x equal to 1 it's also, this function is not differentiable, right? Because at x equal to 1, LHL and RHL is not matching. So if it's not continuous itself, so how it can be differentiable, right? Here they are saying non-differentiable at every natural numbers. That is not correct, right? Discontinuous at every integer, right? They are saying continuous but not differentiable at x equal to 2. At x equal to 2 is perfectly differentiable, because at 2 you can say you will get here, and here LHL, RHL also equal, and LSD and RSD also equal. So here we can easily see that option C, which is showing non-differentiable at x equal to 0 and 1 only. So C will be correct answer, right? So we can say non-differentiable at x equal to 0 and 1 only. Got it? Let's move to the next question. Question number 6 says, by using 2, 4, 5, 7, 8, 9, how many 3-digit numbers are formed in the form of x, y, z, where x is less than y and z is less than y, which means y should be greater. Okay. So we need to form those kind of number. I need to form 3-digit number such that x should be less than y and y should be greater than z. So let's make the cases, right? So I cannot start with 4 because I need that my x should be less than y and y should be greater than z. Y minimum should be 5, right? If y is 5, then what are the possibilities? If y is 5, then how many ways you can fill the first box? We have two options, either 2 can come or 4 can come. After then, we have that y should be greater than z also, right? Then if you talk about this, if I'm putting 5 here, then there are 2 ways in which I can fill this, right? But now there's a problem, because if you fill this in 2 way, but after 5, then I know, let's say if I put it 2 here, then only number is left is 4. So in order to fill the last box, I'll be left with only one option, right? I'll be left with only one option. So there is only one option. So if the middle digit is 5, then how many such numbers will be there? 2 into 1 will be 2. If I just want to show you also, x is less than y and y is greater than z. So you can see that one number will be 254. So here middle, basically we want middle digit to be the greatest. Another possibility will be 4, 5, 2. Got it? Moving ahead with the next case. This is the case number 1. Case number 2. Case number 2, what will happen? If the middle digit is 7. Okay, because like that we need to take all the 4 cases, 5, 7, 8 and 9. If you take 7, what are the ways in which we can fill the first box? The 2, 4, 5, 3 ways we can fill. Since repetition is not allowed, so last box we can fill in a 2 way. So like this, if the middle digit is 7, then there will be total 6 cases, right? Case number 3. If middle digit is 8, how many ways you can fill the first box? So 2, 4, 5, 7, anything can come. So 4 ways, and here we'll be getting 3 ways. So 4 into 3 will be 12. Got it? Now, what if last case, if middle digit is 9? Middle digit is 9. So first, in order to fill the first box, I can use 1, 2, 3, 4, 5, any of the 5 numbers, and next can be filled in 4 ways. 5 into 4 will be 20. Got it? Now, we can easily add all these numbers and we can check our answer, right? So if you check our answer, 2 plus 6, 8 plus 12, 20 plus 20 will be 14. So we can say option B will be correct answer, right? So only the thing is we need to make cases and then we need to add the answer of all the cases. Got it? So this is our answer. 40 will be the correct answer. Let's move to the next question. If 16x square plus 4y square plus z square equal to this expression, then we need to check x, y, z are in which one, whether AP, GP or HP. So we are getting 16x square, 4y square plus z square equals to, if you multiply here, 2yz and 4xz plus 8xy. This is what we are getting, right? Now, what we need to do is, if you just observe carefully here, this 16x square can be written as a 4x whole square. This is 2y whole square and this is z square, right? If you look at this, 2yz is nothing but 2y into z. 4xz is nothing but 4x into z plus 8xy is nothing but 4x into 2y. Okay. And this is what we already know. For the time being, if I assume 4x as a number, this is a B, this is a C, right? So basically I'm getting A square plus B square plus C square equals to AB plus BC plus CA. Okay. We know that this result is applicable only if either all numbers are 0 or all numbers are equal. So we can say A equals to B equals to C, or all are 0. 0 is with respect to like when all are equal only, right? Now, so what will happen is, so we know that if this result happens, then A equal to B equal to C. That simply means 4x equals to 2y equals to EZ, right? So let's assume this entire ratio is equal to K. So if I find the value of x, that comes out to be K by 4. If we want to find the value of y, which comes out to be K by 2, and Z is as usual K. Now we can easily see that these three terms x, y, z are in GP, because if you take first term K by 4, then K by 2, and K, which means that if you look at the three terms, the ratio is constant. If you find like whether x by y or y by z or x by z, that will be same. That means in this is a geometric progression. We are forming first three terms. This is the first term, and the common ratio will become K by 2, which means that these three terms will be in GP. Okay, so this is how we can easily do this. So here option B, GP, is the correct answer. Moving ahead with the next question. The value of this we need to find. Okay, so let's say how we can do this. R into 20 minus R and 20 CR whole square. So sigma R equals to 0, and this 20 CR whole square I can split into two parts. First of all, R into 20 CR I can take one bracket. Another bracket I can take 20 minus R into 20 CR, but R can be written as 20 C 20 minus R, because of NCR equal to NC n minus R. And here we know one property, that R into NCR can be nothing but n minus 1 CR minus 1. So this property I'm going to apply over here. And now one more thing to understand here, instead of starting with R equal to 0, I can start with 1 also, because if you put R equal to 0, anyway this expression is going to become 0 at R equal to 0. Now, so if you apply this property over here, so my R equal to 1 to 20, so I'll get 20 times 19 CR minus 1. And here what will happen? 20, we need to copy here, 19 CR minus 1. So 19 minus R, right? So what we can take common, 20 into 20, 400. So 400 we can take outside. I'll be getting sigma R equals to 1 to 20, and 19 CR minus 1 into 19 C 19 minus R. Right? Now, one more important thing to observe here. If you put R equal to 0, it will be 0. And if you put R equal to 20, 20 minus 20, 0. So instead of taking up to 20, I can take up to 19 only. The logic being, because I can't put 20 here, because otherwise 19 minus 20 will become negative, and we cannot have negative value of here, right? Because in NCR, N and R both should be whole numbers. So now we have an important concept here. If I am having this thing, sigma MCR, and we have NC n minus R, and R goes from 0 to the M, or maybe let's say between M and N, M is less than N, right? So this value will always be M plus N C. What is the sum of these two numbers, which is constant, right? Which is equal to N. So here also, what is the same, exactly same thing is happening. If you look at here, R is going from 1 to 19, and here the sum of these two subscript is constant, which is 18. So what will happen? Here I am getting 400 into, so my answer will be M plus N. So 19 plus 19 will be 38. C, if you add 19 minus 1, 18. So 400 into 38 C 18. But the 38 C 18 is not given. So we can apply this property. Which property? NCR equal to NC n minus R. So we'll get 400 into 38 C 20. 400 into 38 C 20, which is given in option D, right? So this is how we can solve this problem. So this property we need to keep in mind. Other than that, this is also very, very important for us, right? Let's move to the next one. So let's see the answer first. Option D, 400 times 38 C20. Next question, find the value of integral of root secant x minus 1. So here what will happen? First of all, secant x can be written as a 1 by cos x. So if you take the LCM, so you'll be simply getting root 1 minus cos x by cos x. Now we can apply the formula root 1 minus cos x, or we can say 1 minus cos x is nothing but 2 sine square theta by 2, right? And denominator I am getting cos x, and cos x can be written as a 2 cos square x by 2 minus 1, right? Because this double angle formula, if you remember, 1 minus cos 2 theta is 2 sine square theta, and cos 2 theta is 2 cos square theta minus 1. So first of all, we'll try to take something common. Here 2 is there. If you take the common, we'll get root 2 here. And here numerator will be left with sine x by 2, and denominator will be getting 2 cos square x by 2 minus 1. So from the denominator also, if you take the 2 common, so here I'll get root 2 square root of cos x by 2 whole square minus 1 square, right? Now here I can easily take, let cos of x by 2 equals to t. Cos of x by 2 equals to t. Now differentiate it. So derivative of cos of x by 2 is minus 1 by 2 into sine x by 2 equals to dt. 1 by 2 will go to that side. So I'll be getting sine x by 2 dx will be minus dt. So from here, if you simplify, I'll be getting minus of dt upon root of t square minus 1. So if we, this is the standard formula, log of t plus root of t square minus 1 plus c. Value of t we can substitute. T is nothing but a, and here, okay, here when we took the 2 common, so we should know that here we'll be getting 1 by root 2 whole square, because when I'm taking common, I need to take the common from both the terms, right? So here I'll be getting 1 by root 2 square, which is 1 by 2. So here also 1 by 2. So minus of log t value, t which is nothing but cos of x by 2 plus root of t square. T square is nothing but cos square x by 2 minus half and plus c. Now we can easily check with the option and tell the answer. Here you can easily see minus of, and one more thing here we need to understand, that minus 1 by 2 is there. So when this minus 1 by 2 will go to that side, right? So it will become minus 2 times dt. So here also 2 should reflect, here also 2 should reflect, here also 2 should reflect. Now you can easily see option C will be correct answer for this question, right? Option C will be correct answer, right? Now next question. The differential equation represents a family of curve given by the equation. Basically, we need to solve this differential equation. So first of all, what we can do is, we need to remove cos square y from here, because it looks like a differential equation reducible to linear differential equation. So if you just divide both sides by cos square y, so it will become secant square y here, 1 by x, sine 2y. Sine 2y is nothing but 2 sine y cos y divided by cos square y equal to x cube. So I'll be getting secant square y dy upon dx plus cos y will get cancelled, and sine by cos will become 10. So I'll be getting 10y equals to x cube. Now this differential equation, what we can do is, I can put 10y equal to some other variable, because derivative of 10y is already present over here. So I can write, let 10y equal to v, that implies derivative of 10y is secant square y dy upon dx equal to dv by dx. Now we'll get dv by dx plus 2 by x times v equal to x cube. Now we can see this is nothing but the standard format of a linear differential equation, in which this quantity will be called as a p and this expression will be q. So first of all, in this one I need to find integrating factor, which is nothing but e to the power integral p dx. If you integrate, integral of 1 by x will be log x. By the property of log, what will happen? We'll get log x square. So from here I'll be getting x square, right? Now we found integrating factor. Now we need to write the general solution. So that is given by v times integrating factor equal to integral of q times integrating factor, right? So v is what? V is equal to 10y. So we'll write 10y into integrating factor, which is x square, equals to integral of q. Q is x cube and integrating factor is x square, which is x power 5. And finally we need to put plus c, right? Or maybe plus c we can put later also after integration also. That's perfectly fine. So 10y into x square equals to integral of x power 5, which is x power 6 by 6 plus c. So we'll get 6 times 10y into x square equal to x power 6 plus 6c. Since c is arbitrary constant, so 6c will also be arbitrary constant. So again, we can call it as a capital C. Right? So we can check with the option. Option B will be perfectly matching over here. Right? Option B is perfectly matching here. Right? Let's move to the next question. Now they're asking, in this question, they're asking for the definite integral, right? So first of all, if you look at limits are given from 0 to pi by 4. And we know that pi by 4 is less than 1, right? Since pi by 4 is less than 1, then definitely box of x will be 0. Since x is between 0 to 1, so box of x will be 0. So now my question has become 0 to pi by 4, 10 power 6x, 10 power 4x dx, right? Now I can take 10 power 4x common from here. So the moment you take 10 power 4x common, you'll get 10 square x plus 1, which is nothing but a secant square x, right? Now here what you can do, here you can put 10x equal to t. The moment you put 10x equal to t, you need to change the limits. So we'll say that here, when x equals to 0, then what is the value of t? T also comes out to be 0, right? And you'll see when x equals to pi by 4, then my t also comes out to be 1. So what will happen here? And 10x derivative will be how much? Secant square x dx equal to dt. So basically this entire integral we are converting in terms of variable t. So limits will become 0 to 1 and this will become t power 4 dt. Integral of t power 4 we know very well, 1 by 5 t power 5 and 0 to 1. Further simplifying, we'll be getting 1 by 5, which is given in option B. Option B, 1 by 5. Okay, so this is how we can do this question. So let's check the option. 1 by 5 is the correct answer, right? Let's look at this question. They are saying for each x belongs to R, box x be the greatest integer function, and we need to evaluate this limit. So one thing to understand, if x is tending to negative, right? So basically my x is somewhere between -1 to 0, right? But it's very, very close to 0, towards 0. So if you talk about the box of x, in that case, box of x will be simply -1, right? So if you simplify now, limit x tends to 0 minus x is there, and box of x will be -1. And one more thing, since x is negative, so mode will open with the negative sign, right? Mode will open with the negative sign. So it will become minus x. Sign of box of x we already know, -1 divided by mode of x will open with the minus sign. So further simplifying, x and x will get cancelled. So I'll be getting 1 plus x. So basically, limit x tends to 0 negative 1 plus x and sign of -1, right? So if x is tending to 0, I can easily see my answer comes out to be minus of sign 1, and that we can easily see in the option, that is option A, right? Option A, minus sign 1. Got it? Now, let's move to the next question. If f of x is equal to this, is a monotonically decreasing function in x in the largest possible interval this, then we need to find the lambda. So, in order to find the monotonic behavior, first of all, I need to differentiate, which is 3x square plus 8x plus lambda. For monotonically decreasing, it should be less than equal to 0. And they are saying this is monotonically decreasing in this interval, largest possible interval, minus 2 to minus 2 by 3. Now, two possibilities are there, that either I can get this kind of parabola where minus 2 by 3 is here and minus 2 is here, right? But this is not the largest possible interval, because after minus 2 by 3 also something else is there. Other possibilities can be that minus 2 and minus 2 by 3 can be the roots of this quadratic equation, right? Because if you look at this, I'm getting 3x squared plus 8x plus lambda. So leading coefficient is positive, it is going to be parabola upward. Since it has to be decreasing, so my graph has to intersect x-axis. Now, this is the one possibility, this is another possibility, but they have used the word largest possible interval. That is only possible if minus 2 and minus 2 by 3 should be the root of this quadratic equation. That implies 3x square plus 8x plus lambda equals to 0 will have the two roots, minus 2 and a minus 2 by 3. Apply product of root. So product of root will be equal to c by a, which is lambda by 3. Simplify, you will get lambda equals to 4. So you can see the answer. Option A should match, right? If you look at this, option A, lambda equal to 4 is the correct answer. Clear? Moving ahead, the next question. If alpha, beta, gamma are the real roots of this equation, then we need to find the centroid of the triangle whose vertices are this. Okay. So first of all, let's say x cubed minus 3px square plus 3qx minus 1 equals to 0. And this has three roots, alpha, beta, and gamma. So from here I can find one thing, which is alpha plus beta plus gamma, sum of root, which is minus b by a. So I'll be getting 3p. And sum of product of root taken two at a time, alpha, beta, beta, gamma, gamma, alpha, which is c by a, 3q. And product of root, alpha, beta, gamma, that will be minus b by a, c by a, minus d by a, that will be 1. Right? This is a very basic thing you already know. Now they are saying find the centroid of the triangle. So centroid of the triangle we know. Let's say if I say this is x1, y, x1, y1, x2, y2, x3, y3, right? So if we just draw the triangle over here, and vertices are alpha 1 by alpha, beta 1 by beta, c will be gamma 1 by gamma. So now what will happen? We need to find the centroid. For centroid, what formula we have? Sum of x coordinate by 3. So alpha plus beta plus gamma by 3, comma, sum of y coordinates by 3, which is 1 by alpha, 1 by beta plus 1 by gamma by 3. So we have alpha plus beta plus gamma, which is 3p. 3p by 3 will be p, comma. If you simplify this, here you will get alpha beta, beta gamma, gamma alpha divided by alpha beta gamma, right? Whole divided by 3. Now we just simply need to put the value. Alpha beta plus gamma alpha is nothing but 3q divided by alpha beta gamma, which is 1, and whole divided by 3. So my centroid comes out to be p comma q. And p comma q is given in option C, right? So now we can check with the option. P comma q is given in option C. This is how we can easily find the answer. Now, here what we need to do is, next question. The mean deviation about the mean of set of first n natural numbers we need to find. Mean deviation. Okay. So first of all, let's say we have n numbers. 1, 2, 3, 4, 5, all the way up to n. So first of all, I want to find their mean. Mean, how do you find? Sum of all the numbers divided by total numbers. So sum of all the numbers will be n n plus 1 by 2 whole divided by n. So I'll be getting n plus 1 by 2, right? Now the mean deviation we need to find, right? So in order to find the mean deviation, what we need to do, from each number, like because mean deviation is nothing but like from each number we need to subtract the mean and take the mode, and we have to basically add the sum of all the deviations we need to do, right? So if you think about it, here I'll be getting 1 minus n plus 1 by 2 mode, right? Then we'll be doing 2 minus n plus 1 by 2 mode, 3 minus n plus 1 by 2 mode, keep on going. And in the end, what will happen? I'll be doing n minus n plus 1 by 2 mode divided by how many numbers are there, which is equal to n, right? And they are saying mean deviation about the mean of set of first n natural number when n is the odd number, right? If n is the odd number, then definitely there will be exactly one middle term. There will be exactly one middle term, right? So if I'm going like 1, 2, 3, so if n is the odd number, then middle term will always be n plus 1 by 2. So somewhere in between, I'll be having middle term, which will be n plus 1 by 2, then again n plus 1 by 2. So after this, it will continue like this, right? So here, if you look at this, if you simplify, what will happen? You will be getting 2 minus 1, 1, 1 minus n by 2. But we know that here n plus 1 by 2 will be greater than 1. So here we need to do n plus 1 by 2 minus 1. So it will become n minus 1 by 2 plus here also n plus 1 by 2 will be greater than 2. So if you simplify, you will get n minus 3 by 2. Got it? And next, you can follow the pattern n minus 5 by 2 keeps on going. Got it? So n 1, 3, 5 keeps on going up to here. And in between, what will happen? This n plus 1 by 2 and n plus 1 by 2 will become 0, right? Now, we want to know what term will reflect here, right? Because then only we can apply the sum of the AP formula. So before n plus 1 by 2, what will the one term before? That will be n plus 1 by 2 minus 1, which will be n minus 3 by 2, right? So I want to write this deviation over here. So this deviation, if you see, I'll be getting n minus 3 by 2 minus of n plus 1 by 2. This deviation. If you simplify this, what will happen? We'll be getting here, if you take the LCM, n and n will get cancelled, minus 3 and minus 1, right? So minus 3 and minus 1, minus 4, minus 4 by 2 will be 2. So basically, I'll be getting 2 over here, okay? Like this, it will be keep on going. Similarly, from here onwards, what will happen? Like from here onwards, if you look at the last term, 2n, so basically here I'll be getting 2n minus n. So I'll be getting n minus 1 by 2 over here, right? Same story will repeat here. Basically, this n minus 1 by 2 and this n minus 1 by 2 is matching. So here n minus 3 by 2 is coming. So here also what will happen? Same n minus 3 by 2 will come. So it will be keep on going. And in the end, here also will be getting 2 only, right? So basically, this series, entire this series and this series is exactly same. So if you want to find the sum, okay, so because that's total divided by n, right? Total divided by n. So we need to see that what we are getting. Basically, this series and this series are same. So I can easily see that this is going to be 2 times of sum of this series, which is n minus 1 by 2 plus n minus 3 by 2 plus n minus 5 by 2 and n minus 7 by 2 all the way up to 2 and divided by n. So here we can say that this is nothing but an arithmetic progression, right? Is an arithmetic progression. So now if you look at this, total number of terms if you talk about, because if you talk about overall the total number of terms are n, out of n, this middle term will be n plus 1 by 2 term, right? This will come at the n plus 1 by 2th position. So before n plus 1 by 2th position, how many terms would have come? Because total number of terms I require, that will be n. So what we can do is, here we need to find the sum of all the terms, divided by n, multiply by 2, we'll get the answer, right? So if you think about it, If I say, let's consider the 5 numbers, 1, 2, 3, 4, and 5. If I say n equal to 5, right? N equal to 5. So 3 will be the middle term, right? And before that, how many terms will be coming? Which is nothing but 2 terms. And after that also, how many terms are coming? 2 terms. That is nothing but what I can do is, first of all, I can find the middle term. Like if I want to know how many terms are coming before the middle term. So 3, how it came, which is nothing but n plus 1 by 2. Okay. From the n plus 1 by 2. Okay. Or we can do it this way also. Let's say total number of terms are n. From the n, if I can remove up to this, or maybe if I can remove up to this many terms, because this side 4, 5, and 1, 2 will give the equal number of terms. From the n, if I can remove up to this many terms, which is nothing but n plus 1 by 2. So what will happen? I'll be getting n minus 1 by 2 terms, right? Which means here n minus 1 by 2 terms, here also n minus 1 by 2 terms. So what will happen? You will be getting 2n minus 2 by 1, n minus 1, and this is the 1 term, which means that before that n minus 1 by 2 terms will come, right? So if I talk about here to here, how many terms are there? N minus 1 by 2 terms is there, right? So now what I can see that this is nothing but a simple arithmetic progression, right? And if you apply the sum of terms, right? If you apply the sum of n minus 1 by 2 terms of AP, okay? So if you apply this formula, so we can say n by 2. So number of terms will be basically n minus 1 by 2, n by 2, and first term plus last term. First term plus last term we can apply, right? First term plus last term, or we can apply 2a plus n minus 1 times b. First term plus last term, right? So this is nothing but n by 2, first term plus last term, whole divided by n. Got it? So further what you need to do is, you just need to simplify this and you will be able to get your answer, right? So if you just check over here, same kind of situation is they are telling over here. So so from here we are getting 1 minus n plus 1 by 2. So what we did basically is, in order to find the mean deviation, we took it. So we understood that in between 50% of the term, I'll be getting all these things with negative sign. Remaining 50% of the term I'll be getting with the positive sign, right? So what I did is, basically I got this n is coming because of this n. So I got 2 times 1 plus 2 plus 3 plus up to here, and I'll be getting total n minus 1 by 2 terms. Then here we have applied the sum of n terms, right? Sum of n terms of AP. Then we simplified it. We got n square minus 1 by 4n, right? And in our formula, some small mistake we have done. Let me check, because we should be getting 1 plus 2 plus 3 plus and so on. So let me check what we have done here. So if you check it here, 2 minus 1 1 and minus 1 by 2 to the 4, 4 minus 1 3. So basically 4 minus 1 3, n plus 3 by 2. Okay, so n plus 1 by 2, n plus 3 by 2, n plus 5 by 2, all the way up to 2. Okay, so this seems correct only. Let me check how this 2 came. Oh, here we have done mistake. The mistake what we did is, basically if you look at this, n plus 1 by 2 minus of n. So basically 1 plus 1 2, and if you divide 2 by 2, that this will be basically 1. So that's the mistake we did. So here also we need to take 1. Yes, this mistake we did. So once you simplify this, after this you will be able to get your option B, n square minus 1 by 4. Got it? So this is how we can easily find the mean deviation. Now you can see the option B, n square minus 1 by 4. Got it? Now next question, two circles whose radii are equal to 4 and 8 intersect at right angle, the length of their common chord. So basically they are saying there are two circles, their radius are 4 and 8. So let's say this is C2, C1. They are intersecting at a right angle. So let's say this is 4, this is 8. Okay. they're intersecting at the right angle, so we need to find the common chord. So basically I want to find this PQ length we need to find. Okay, so for example, if I take this angle as a theta, okay, so and I know that this length is going to be total 90 degree. I mean this angle is 90 degree. So in triangle PC1C2, in triangle PC1C2, if you try to find the value of tan theta, what is tan theta? Opposite by adjacent, which is 8 by 4. 8 by 4 is nothing but 2. If tan theta is 2, then what will be the sine theta? That is going to be 2 by root 5, right? Now, smaller triangle. Let me take this point as a M. So, in triangle PMC2, if you apply sine theta, then what will happen? I'll be getting opposite by hypotenuse. So, we'll be getting PM equals to 4 sine theta. So, sine theta value is nothing but 2 by root 5. So, I'll be getting 8 by root 5. Right? So, 8 by root 5 is the value of PM. So, PQ will be double of that. That should be 16 by root 5. That should be 16 by root 5. Got it? 16 by root 5. This is how we can do it. Next question. If the shortest distance between straight lines is equal to this 1 by root 30th integral value of lambda. Very simple. This is straightforward question. First of all, if you look at your line, we need to convert into the standard form. Here 3, 6 and 2. So we divide this by 6. So I'll be getting 2 here. Y minus 2 divided by 1 equals to Ez minus 1 by 3. Right? So here, if you just select what is A1 vector, which means the point from which my line is passing, so that will be I cap plus 2j cap plus k cap. And if you talk about the parallel vector, that will be 2i cap plus j cap plus 3k cap. Okay. Similarly, for the second line over here, we need to divide by 2. So I'll be getting x minus 2 by 2 equals to y minus lambda by 1 equals to z minus 3 by 1. Z minus 3 by 2. So here if you look at the point from which my line is passing is 2ik plus lambda jk plus 3k. And B2 vector, parallel vector will be 2ik plus jk plus 2k. Okay. Now shortest distance, we have the formula, that is mode of A2 minus A1 vector dot B1 cross B2 vector divided by mode of B1 cross B2 vector mode. Now what we need to do, just need to put the values here. So how do we calculate numerator? So A2 minus A1. 2 minus 1 is 1, lambda minus 2, and 3 minus 1 is 2. And B1 vector and B2. So B1 vector will be 2, 1, 3. B2 vector will be 2, 1, 2. So this is the numerator. Denominator, first we need to multiply B1 and B2. Let's find B1 vector cross B2 vector separately. So I cap, j cap, k cap, and here what will happen? 2, 1, 3, 2, 1, 2. If you simplify this, 2 minus 3, so I'll be getting minus I cap, 4 minus 6 minus 2, so I'll be getting plus 2 j cap and 0 k cap, right? So numerator you can simplify. If you expand along the first row, 2 minus 3 minus 1, minus of lambda minus 2, 4 minus 6 minus 2, 2 times 0. This mode divided by 4 plus 1 root 5, right? Because 2 square is 4, 4 plus 1 will be root 5. Okay. And this length you can compare equal to 1 by root 30, because this is the distance between two lines, right? Shortest distance between two lines. Got it? Now all you need to do is just square both sides and find the value of lambda. Okay. So from here you just square both sides and you will be able to get the value of lambda. So let's just check that quickly. Calculation part once. 2 minus 1 1 and lambda minus 2, 3 minus 2 is 3 minus 1 is 2. This is perfectly fine. First vector component 2, 1, 3, 2, 1, 2. Here 2, 1, 3, 2, 1, 2. So if I'm taking this thing, so 2 minus 3 minus j, if I'm 4 minus 6 minus 2 plus 2, 2 minus 2, 0. So root 5, this is what we'll be getting. Okay. So, and here, let me check again. If you divide by 6, 2, and here 1, and if you divide by 6, it will become 3. 1, 2, 1, 2, 1, 3. And in this one, if you divide by 2, x minus 2 by 2, y minus lambda 1 by z minus 3 by 2. So 2, 1, 2, 2 lambda 3. Everything is perfect. Okay. And here, when you take j, 4 minus 6 minus 2, and then again plus 2, right? So from here, you can easily find the value of lambda. Just square both sides, and you will be able to get it. Clear? So if you look at the answer, so I'm getting this as a root 38. Got it? So root 38, and if you simplify, you can easily get the value of lambda, which is given in option A. Now, 18th question. If omega is the cube root of unity and two of the factors are of this form, then we need to find the value of this. Okay. A plus B omega power P plus C. Then basically we need to find the value of this. Okay. So what we can do is basically, this is a very standard. If you say this is A, B, C, and here we are getting BCA and CAB. This is a very standard determinant, if you should know, ABC, BC, and CAB, right? So this has, they are saying two of the factors are this, right? So what we can do over here is, if you look at this, so this one has the two factors basically. If you open this, so we'll get something like a cube. Okay, so we'll get 3abc minus a cube minus b cube minus c cube, right? If you expand this, you'll get this. From here, if you take minus common, you'll get minus of a cube plus b cube plus c cube minus 3abc, right? And this one we know it has the three factors. First is a plus b plus c. Another is a plus b omega plus c omega square. And another will be a plus b omega square c omega. This is what it will have. Now this thing, as they are saying, this has two factors like this. So we need to compare the value of p and q. So you can see, if I'm putting a plus b omega power p, if I assume the value of p equals to 1 here, then q also I need to take 1, right? Let's say if I compare with this, so q value 2. So basically, if you compare these two factors and powers you compare, you'll get p and q both will become 1. So both are 1 means I'll be getting 2 as my answer. Got it? 2 as my answer. Next, if a vector and b vector are non-zero vectors such that a plus b equals to a minus 2b, then we need to find which of the following option is correct. So first of all, if we square both sides, what will happen? A plus b square equal to a minus 2b square. So I'll be getting mod a square plus mod b square minus 2 plus 2 a dot b equals to I'll be getting mod a square plus 4 times mod b square minus 4 a dot b. So from here I can say 6 times a dot b equals to mod a square will get cancelled, so I'll be getting 3 times mod b square. So I'll be getting a dot b is equal to 1 by 2 mod b square, right? So a dot b is 1 by 2 mod b square. So a and b can't be correct. Let's focus on c and d. So least value of this we need to comment, right? So let's find a dot b first. So a dot b equal to this quantity. So if I say this entire expression equal to E, so let's say E equal to a dot b plus 4 by mod b square plus 2. So a dot b value we know, half of mod b square plus 4 times mod b square plus 2. Okay. So we need to apply the AMGM. Before that, I need to make this term and this term exactly same. So what I'll do is, I'll just add 2 and subtract 2. So if you add 2 and subtract 2, what will happen? I am going to get 1 here. So between these two terms, if you apply the AMGM, okay. So if I say, let's say this term is x and this term is y. So if I say x plus y by 2 will be greater than equal to root xy, right? So if you look at this, so product of both the numbers will be 2, so root 2, which means that x plus y is going to be greater than or equal to 2 root 2. So sum of these number will be 2 root greater than equal to 2 root 2. So overall number will be greater than equal to 2 root 2 minus 1. So the least value will be 2 root 2 minus 1. So option D will be correct answer. Option D will be correct answer. I hope this is clear. So option D will be correct answer, which is the least value, right? Now let's move to the next questions. Integer types. Okay, before that we have left one more question, right? What is this question? Each of the person A and B independently tosses 3 fair coins, and the probability that both of them get the same number of head and tail. Okay. So what we need to do basically, this is the question from the binomial distribution. So basically what is happening is, independently they're tossing. So let's say P equals to, P is the success, same number of head. So head is 1 by 2. So tail is 1 by 2. So they should get the same number of head. That simply means P x equal to 0. Let's say first person is not getting head. Second person also not getting head. 0 number of head. Second is x equal to 1 and P y equal to 1, which means both are getting 1 head. Here x equal to 2 and this also y, another person also getting 2 head. Third is x equal to 3 and P y equals to 3. Now we just need to plug in the values. X equal to 0, what will happen? We'll be getting 3C0 1 by 2 whole power 3, right? Because formula is NCR, P power R, Q power N minus R. So here square, because for this and this it will be same. Here 3C1 1 by 2 whole power 3 and whole square. For 2 also 3C2 1 by 2 whole power 3, it will be whole square, and last 3C3 1 by 2 whole power 3 whole cube. Okay, this quantity we can simplify and we can give the answer. Like 3C0 is 1 by 2 power 6. So 2 power 5 is 32, so it will be 1 by 64. 3 power 2, 6 again, so 1 by 64. So basically you'll getting 1 by 64. 1 by 64 overall come common. We'll be getting like 3C0, 3C0 square, 3C1 square plus 3C2 square plus 3C3 square. So what will happen? You can just simplify this and calculate. You will be getting option B 5 by 16 as a correct answer. Got it? Now next, mod Z1 equals to 2, Z2 is 3. Then we need to find this value. Okay. This value we need to calculate. So let's look at this, how we can find this. Here 8, 27 and 64 they have given. Okay, and this value 2Z1 plus 3Z2 plus 4Z3 is equal to 9. So what we can do basically, they're asking me to find this value, right? 8 Z2 Z3, 27 Z3 Z1 plus 64 Z1 Z2. So what will happen? Here if you multiply and divide by Z1, so I'll get Z1 Z2 Z3 divided by Z1. Similarly, here if you multiply and divide by Z2, so Z1 Z2 Z3 divided by Z2. Plus here if you multiply and divide by Z3, so this is what I get. Now I can say Z1 Z2 Z3 is everywhere, so I can take it common. So mod Z1 Z2 Z3 I took common. So I'll be getting 8 by Z1, 27 by Z2 plus 64 by Z3. Now for any complex number we know that 1 by Z, this inverse is defined as a Z bar upon mod Z square. So here I can write Z1, Z2, Z3. 1 by Z1 can be written as 8 times Z1 bar divided by mod Z1 square. Z1 is given to 2 square is 4. Same here, 27 by 27 times Z2 bar mod Z2 square. Mod Z2 is 3, 3 square is 9, plus 64 by Z3 bar divided by mod Z3 square will be 60. So if you calculate, you will get mod Z1, mod Z2, mod Z3. So I'll be getting 2 Z1 bar plus 3 Z2 bar plus 4 Z3 bar. And this value we already know, 2 into 3 into 4 into. Now we know this property. If there individual bar is there, we can remove this bar, right? Because we know this property, Z1 plus Z2 bar is equal to mod of Z1 plus Z2. So we can remove the bar, 2Z1 plus 3Z2 plus 4Z2. This value we already know, that is 9. So my final answer will be 2 into 3 into 4 into 9. So this will be our final answer, right? So this is how we can calculate the value. Now moving ahead with the next question. They are saying if A is a square matrix of order 3 and determinant is given 2, then this value we need to find. And here we know very well, if A is any matrix, if A is any square matrix, okay, if A is any square matrix, okay, then what will happen? A minus A transpose will always be skew symmetric matrix, right? Skew symmetric matrix. If A minus A transpose skew symmetric matrix of odd order, then determinant will always be 0, right? So here if you look at this, here power 5 and determinant. So this can be written as A minus A transpose, determinant whole power 5. Here it can be written as A transpose minus A whole power. Since this determinant will be 0, both are skew symmetric matrix, so overall answer will become 0, right? So this property you should keep in mind. The determinant of skew symmetric matrix of odd order will be 0, right? So moving ahead with the next question. What they are saying, this value they are asking. Sine pi by 14, 3, 5, 9, 11 and 13. Okay. If you look at this, sine 13 pi by 14, if I want to reduce, this can be written as a pi minus pi by 14. And sine pi minus theta is sine theta, which means that sine pi by 14 is equal to sine 13 pi by 14. Similarly, these two values are equal and these two values are equal. So effectively, if I say, I'll be getting sine pi by 14, 3 pi by 14 and sine 5 pi by 14 whole square, right? Now, we want to convert them into cos. So sine pi by 14, if you convert them into cos, what will happen? 4 pi by 14, right? 4 pi by 14, which is 2 pi by 7. And if you convert into cos, basically I'm applying sine theta equal to cos 90 minus theta. So 4 pi by, if you apply here, so pi by 2, 7, 4 minus 3, 1. So here what will happen? Sine 3 pi by 14. So I can apply cos pi by 2 minus 3 pi by 14. 7 minus 3, 4. 4 pi by 14, 2 pi by 7, right? So it will be coming, here it will become cos pi by 7, 2 pi by 7. And here, if I put 5, 5, 7 minus 7 minus 5, 2. It will become 2 pi by 14, cos pi by 7. Basically, I'll be getting cos pi by 7, cos 2 pi by 7, and 7 minus 6 pi by 14. 6 pi by 14 will be, if you just look at this here, let me just write it here. So this sine pi by 14, what I can do? I can write it as a cos pi by 2 minus pi by 14. So 7, if you multiply 7 pi by 14 minus pi by 14, which is nothing but a 7 pi by 14 minus pi by 14, 6 pi by 14, which will be 3 pi by 7. Cos 3 pi by 7. And cos 3 pi by 7, if you reduce it, cos 3 pi by 7 can be written as a minus of cos pi minus theta, which is further minus of cos pi by 4 pi by 7. But because of square, we can directly write it as a, first of all, if I write cos pi by 7, next term 2 pi by 7, and the next term cos 4 pi by 7 square. Here we are getting a series, cos series. What series? Cos theta, cos 2 theta, cos 2 square theta, all the way up to cos of 2 power n minus 1 theta. This series is nothing but sine of 2 power n theta divided by 2 power n sine theta when angles are in GP. So basically, if I apply here, so I'll be getting 2 power n. So number of terms are 3. Sine 8 pi by 7 divided by 2 power n, 2 power sine 2 power n. So basically here it won't come. 2 power n means 2 power 3 is 8, and here I'll get sine pi by 7. So basically what will happen? Sine 8 pi by 7 and sine pi by 7 will be negative of each other. They will get cancelled. So I'll be getting 128 divided by 8 square. So 8 into 8. So this is 64 times 2, and here we'll get 8 into 8. 8 will cancel 8 times. 8 to the 16. 16 by 8 will be 2. So this is how we can easily find the answer for this question. So the idea is to convert this into in terms of sine first of all, then again convert in terms of cos, then apply the cosine series. Right? Let's look at the second last question. They are saying if y equals to this, then we need to find the dy over dx we need to find. Okay. So if you look at this is a very simple question, because we know that secant inverse of t will be nothing but cos inverse of 1 by t, right? So if I want to convert this secant into cos inverse, so I'll be getting x plus root x divided by root x minus 1. And here I'll be getting sine inverse x plus root x divided by root x minus 1. So we can say that, and these both the arguments are equal. So we know sine inverse plus cos inverse is pi by 2. So I'm getting y equals to pi by 2. So my dy upon dx will be equals to 0. Since the y equals to constant function, so derivative will be 0. Right? So if you check the answer, it will be 0. Let's look at the last question. If let A be the area bounded by this curve, y equal to x mod x minus 3, x-axis and the ordinates this, then 12 times A we need to find. Okay. So if you look at this, x times mod of x minus 3, right? So if first of all, let me just write the piecewise definition of the function, x times mod x minus 3, right? So if I say that if my x is less than 3, less than or equal to 3, this more x minus 3 will open with the negative sign. So I'll be getting x times 3 minus x. And if x is greater than 3, what will happen? It will open with the positive sign, which is x times x minus 3. Simple. Now I need to find the area bounded between minus 1 to 2. Okay. So if I just want to draw the graph, we'll get more clear picture. So less than equal to 3, I'm getting 3x minus x square. So basically, I want to draw the graph of y equal to 3x minus x square when my x is from minus 1 to 3. This part alone we need to analyze. Okay. So we can say this is going to be a parabola downwards, right? This is going to be a parabola downwards. So first of all, if you look at this, what are the roots of this one? The roots of this will be x equal to 0 and 3. So if I say x equal to 0 and 3, it has to intersect, right? If you talk about x equal to minus 1, if you put minus 1, so I'll be getting minus 3 minus 1, which will give minus 4, right? Which means that if you put x equal to 0, y also 0. And if you put x equal to 3, that also 0, which means these two are the roots of this. Now we want to, if x is equal to minus 1, so what will happen? I'll be getting minus 3 minus 1. So I'll be getting minus 4, right? This is what we'll be getting. So as we can easily see that if I go from minus 1 to 0, okay, without graph also we can do. What we can do, if x is between -1 to 0. So this quantity will be negative, right? So if I want to integrate it, if I go from -1 to 0, I know that this quantity will be negative because x is negative, but 3 minus x minus 3 mode is always positive. So in order to make it positive, we have to open like this, right? Now x is negative, so overall this will be negative, right? So in order to make it positive, since this is 3x minus x square, right? So we need to do x square minus 3x plus. If we go from 0 to 2, then anyway 0 to 2 what will happen? For x which is greater than 0, still I'm in the same definition, but this time what happened is, this time x is positive and 3 minus x also positive. So directly I can do x times 3 minus x dx. X times 3 minus x dx. Okay. Same thing we can do with the help of graph also. We can draw the graph, we can say between -1 to 0. The portion of -1 to 0 graph will be below x-axis, between 0 to 2 it will be above, so directly we can add. So from here x cube by 3 minus 3 by 2 x square -1 to 0. Here we'll get 3x, so 3 by 2 x square and 3x, and here we are getting basically minus x square, so it will be minus x cube by 3, 0 to 2. Now we can just simply put the upper limit minus lower limit and we can calculate it. Got it? And actually here some mistake is there. It should not be 3x minus x square. Basically it should be 3x minus x square. Okay. So finally what you need to do is you just need to plug in the values over here and you'll be able to get the answer. I hope we have discussed all the questions and thank you.